everything is being influenced by code written by developers.
At some point, you're going to wake up and say, what the hell am I doing?
It's hard to believe. It's the largest group I've ever been in front of, I think.
We develop the future.
Hi, and welcome back to our afternoon sessions of WeAreDevelopers Live DevOps Day. So we are going to talk about AI and MLOps, SRE strategies in agencies, CI/CD pipelines, and branching databases in the upcoming 4 sessions. Hope you have your coffee ready. And before we start, again, a couple of reminders. First of all, as you saw it in the video, we are going to have an in-person WeAreDevelopers World Congress in Berlin this June. So check it out on worldcongress.dev, and yeah, make sure to get your tickets at the super early bird price. Next thing is you can see a chat window beside the stream. Feel free to engage with each other and ask your questions to the speakers. After every session, we will have a Q&A part, and the speakers will be happy to give you some answers to everything you want to know. And last but not least, we also have a code of conduct that I would like to ask you to respect it. Here's a short video. Yeah, and just before I forget it, you can win a Nintendo Switch. Just scroll down the page, you will see a promotion by our partner Deloitte, who are also making these kind of events possible. Only thing you have to do is answer a simple question, and you are in the raffle. We are going to announce the winners after the event. So, and with that said, we are going to our first speaker, and it's really a pleasure to announce the first session. Our first speaker is a Google developer expert. She is an OpenAI ambassador. She has worked as a software engineer, as a hardware engineer, as an engineering manager. Today, she works as a head of developer relations at Entor. And yeah, so please give a warm welcome to Natalie.
Thank you very much.
Hi, Natalie. How are you doing?
Great, great. I'm very happy to be here.
That's good to hear. Before we kick off the session, do you want to share a sneak peek, a couple of words about your session? Like, what are we going to learn from you today?
We are going to learn how is the future of DevOps is going to look like with all the AI that is slowly bubbling in, and get some concrete tips and some concrete places where you can sign up to be part of this future.
Okay, that sounds very interesting. So I wish you a lot of fun. We will see each other in the Q&A session. And yeah, the stage is yours.
Thank you, thank you. Okay, so as the short sneak peek, as you heard, we're here to talk about DevOps and AI and how that kind of combines into this fun new term that is called MLOps, or maybe sometimes you hear it as AI Ops. And in the past, I've been giving lots of conference talks about the topic of Go, which is a programming language that is close to my heart, and in machine learning and how those two work, and in DevOps and in infrastructure and SRE and observability and how to begin and all those things. And I always try to have the talks to be less regular in the sense of not just a project that I'm doing or something, but a lot of hands-on things. So you will be seeing links, you will be seeing concrete recommendations, you will be seeing me mentioning tools that I like specifically. And I absolutely encourage you to dive in and get your hands dirty with all those different things so you can actually get the feeling for that. And you can find the slides afterwards probably on the website, and definitely I'll be sharing this on my Twitter handle as well. So you're welcome to follow my handle on Twitter is Natalie Piss, and the conference handle is WeAreDevs. So take pictures, take screenshots, and tweet everything fun and new that you learn to share with your friends and network. So nice to meet you. I am head of developer relations at Entor. This is a new role for this new year, and Entor is a fun company that is still in stealth mode. And getting to be the first employee is so much fun. It's like you get to do all the fun things, but you don't have to do the hard work of being a founder. And I am in the second week there, but this is the mission of Entor, in short, is doing no code. And I think this is absolutely part of the revolution that is coming. That's why I decided to jump into that. And the picture that you see here is a picture that I made on the very last trip that I got to do some 2 years ago or so, around this time. And this trip was a little bit by mistake. And it's one of the wonderful decisions that I had the chance to do, because afterwards, obviously, there was no traveling for quite a while. And I'm very happy that this is kind of the last memories that the phone bumps for me. Another smart decision that I happened to take was to take a job that asked me to learn Go back in 2014. Another decision that I hope to turn out to be smart is to jump into the world of AI engines. And for all sorts of decisions, considerations, smart and less smart, join me on the Go Time podcast every Tuesday. You can find it live on YouTube and later recorded in the different platforms like Spotify. And join one of the communities that I'm organizer at, like the Berlin Go user group, or the Women Tech Makers of Berlin meetup, or one of the conferences like Cloud9, which is about SRE, or GopherCon Europe, which is about the Go programming language. And if you want to contact me about not Go and not this meetup, but actually about AI and OpenAI work that I'm doing, or volunteer that I'm doing, you can join the OpenAI community. This is open for everybody. And there's lots of knowledge sharing and interesting questions and people that are helping each other. And it used to be a wait list, but now OpenAI is welcome and open for everyone. So you can just hop in. And as I mentioned, I love sharing all the different things that I'm working on, that I hope that will kind of connect the dots and so on with time on Twitter. So do follow and do share content from this conference. As a conference organizer myself, I can tell you that seeing activity on social media is so much fun and is really rewarding. So our plan for today is to talk about three main things. The first one being a brief history of AI. So we're kind of all aligned on the same page and actually know why and where and how and so on. Then we'll talk about AI-generated code, and I will give the Go take on that, because I do think this is a wonderful programming language, both for backend and for infrastructure and DevOps. And we'll finish with some predictions that I have for what's coming up to us. In between, I will share some recordings of what OpenAI and the engine CodeX can do. But let's start with some history. So René Descartes and Galileo Galilei regarded thoughts, tastes, odors, and colors as symbolic representations, and perception as an internal process. So you could say that the seeds of AI is something that has been planted a long, long time ago. Then, in 1956, a group of scientists gathered for the Dartmouth Summer Research Project on the topic of artificial intelligence. And by many, this is considered to be the birth of this field as a research. And then started an era that is called the symbolic AI. This is the time when access to digital computers became possible, and a few scientists instinctively recognized that this machine could manipulate numbers, and also it could manipulate symbols. And as we said, the manipulation of symbols could be sort of the essence of the human thought. In the following years, computers were solving algebra problems around the world. They were proving theorems in geometry, and they were learning even how to speak English. Researchers were optimistic, and they predicted that fully intelligent machines is just a few years away. That made government agencies like DARPA pour a lot of money into this field. But mid-70s is when AI researchers realized that they kind of failed to appreciate the difficulty of the problems that they faced, and this general intelligence is actually not that close. While public criticism was going up, and that caused the funding to slowly stop, and that brought the first AI winter, where not much was happening. And then, in the 80s, AI became useful again, this time not as a general AI, but as narrow AI, so more in a specific domain. And AI programs called expert systems were answering questions about the knowledge of the specific company, so their internal knowledge base, and it was saving the industry a lot of money. In addition, Japan launched the 5th generation computer, which is sort of an LLP machine, and they were followed by the UK and the US. Back came the AI funding, and the progress in the field of neural networks and semiconductors enabled the development of practical artificial neural network technology. Then, towards the end of the 80s, Apple and IBM's desktop became more powerful than this expensive, dedicated AI hardware. And this led to this industry of AI-related hardware to collapse. And those expert systems became too expensive to maintain. Once again, DARPA stopped the financing. And in the 90s, AI was doing a comeback. The computational power was now strong and cheap enough, and AI was used to solve specific, not general problems. AI researchers began to develop and use sophisticated mathematical tools more than they ever had in the past, and algorithms that were developed by AI researchers were used in the industry. In 1997, Deep Blue beat Kasparov in chess, as most of us probably remember in some way. And today, we are in the era of AGI and big data. So AGI stands for Artificial General Intelligence, which is, as we said, the ability to solve any problem rather than a solution for a particular problem, which is called narrow AI. The industry problems across the different industries are being solved by big data, plus cheap and fast computers, and advanced machine learning techniques. All the different industries have a lot of data to process, and they increasingly use AI for the different big business logic that they have. So we talked about the history of AI. Now let's zoom in a little bit on the history of AI models. In 2010, IBM DeepMind was founded. In 2014, they joined forces with Google to accelerate the work while continuing to set their own research agenda, and had some amazing achievements like manage and optimize Google's data center energy consumption, and a very recent one, AlphaFold, which is a system that accurately predicts the shape of proteins. 2015 is the year when OpenAI was founded as an AI research and deployment company with a mission to ensure that artificial general intelligence would benefit all of humanity. Reminder that artificial general intelligence is the ability of an agent to understand and learn any task that a human can do, which is also called strong AI. So in 2017, Google AI was founded as a division of Google, and this one was dedicated to artificial intelligence. And the mission was to conduct research that advances the state-of-the-art work in the field and applying AI to products and to new domains. They would develop tools to ensure that everyone can use AI. And then 2018 is when GPT-1 was released. So until now, most of the NLP, which stands for natural language processing models, were trained specifically on a particular task. As we said, that's the narrow AI, not the general one. GPT-1 stands for Generative Pre-trained Transformer, was trained on 117 million parameters, and it performed better than most of the supervised trained models in most tasks with 0 to few shot learning. That means that GPT-3 was not trained to work on a specific task, but actually on a general one about the language, and it performed better than most models that were trained to solve a specific task. This is mind-blowing. And this model was used to do deep learning to produce human-like text. In 2019, GPT-2 was released, trained on 1.5 billion parameters, and of course it had a wonderful zero-shot learning. And in 2020, GPT-3 was released, trained on 175 billion parameters. The zero/few-shot learning performance was outstanding. Zero-shot learning and few-shot learning means that it sees no examples or few examples. And reminder that it is performing as a general model with very little context better than models that were trained to solve a specific task. And the focus of it kept being around writing content, processing content, and working with code. So where is AI today? Let's quickly think on what is the definition of today. Are we all aware that 2050 is closer than 1990? Yikes. Every time I see this meme, I'm like, oh wow. So I hope you share this sentiment. Right, so let's focus on the recent history of AI models. We said that in 2020, GPT-3 was released with 175 billion parameters. Then, last year in 2021, Switch Transformers was open sourced by Google Brain, and the model scales up to 1.6 trillion parameters. But it's worth mentioning that the fact that the model is released does not mean that everybody can just go ahead and use that, because you do need things like hardware to support that. Another thing that happened last year was that WuDao 2.0 was released by the Beijing Academy of Artificial Intelligence. Look at this number. WuDao 2.0 is 10 times larger than OpenAI's model, which is trained on 175 billion parameters. It's just one digit away from the Switch Transformer, but it actually has 150 billion more parameters than Google's Switch Transformer. But according to their website, they have 12 partners who are using this right now, and business entities/companies. So I don't know anybody who is using it today. And a very recent one that was released is the Megatron Turing, created by NVIDIA and Microsoft, back to the scale of billions. I found this nice visual from the NVIDIA developers blog where they announced this model, and that is going all the way up. I found this Reddit post that nicely puts things in proportions. So apparently, we jumped in brain comparison of a mole rat to the one of an octopus. Quite crazy. I took the liberty of adding Google's Switch Transformer and Beijing's Academy of Artificial Intelligence Wudao 2.0. And does that look like a hockey stick or what? For fun, let's add another number. This one is for the model GPT-4. And it's very important for me to say as an OpenAI ambassador at this point that this is not an official number. This is just an estimate that I found on the internet. And it does not have an official release date, but the next GPT model is already in progress. So if the previous one looked like a hockey stick, this one looks like a launching rocket. Now, if you ask yourself, how does this one compare to the brain size? Let me bring you this quote from Stephen Smith, a professor at Stanford. In a human, there are more than 125 trillion synapses just in the cerebral cortex alone. So in the outer layer of the largest part of our brain, which only mammals have, this is the numbers that we're talking at. And this layer is in charge of attention and perception and awareness and thought, memory and language and consciousness. And you know what? You can roughly say that this very mind-blowing fact that the number of parameters in the upcoming GPT model is somewhat on the same scale as the human brain. And another thing that is really worth focusing on is that given that from all the models that we talked about, the GPTs of OpenAI are the only ones who are publicly available. That means that from all the models that we saw, the one that is very huge and the next one that is going to be our rocket are the ones that you can just go on the internet and start immediately interacting with without almost any setup. That's a lot. So enough nerding out about AI models and numbers. Let's talk about how is this relevant for us as developers. Have you heard of CodeX? CodeX is another engine in the family of OpenAI's engines. It is designed to translate natural language into code, and this is the engine that powers GitHub's Copilot. So every time that you go to VS Code and you're using Copilot with a right click, what it does is an API call with your code that is highlighted to this engine. And as with all OpenAI's engine, CodeX is also publicly available. However, for CodeX right now, there is a wait list. So what we will do is jump into some video examples where I'll be walking you through some experiments that I've been doing with CodeX. As we say, it worked well on my machine, but unfortunately now I can not access that screen. So you will have to see a little bit of a drag and drop. Bear with me. All right. So now we are looking at this pre-recorded set of demos. And the reason that it has to be pre-recorded is that according to the usage rights, I am not allowed to do live demos just yet. But I am uploading a lot of this experiments and recordings also to my YouTube channel, to which I will share a link later. So you can see this now and you can see a lot more of that later. Let's watch. So what you can see here is some examples that you see probably from your everyday life. And those are some tasks. So the first thing we'll do is get acquainted with the interface. This is the playground, and this is how you interact with the engines. So you start by choosing an engine. And the OpenAI API family is powered by different models with different capabilities. The base series is the one that understands natural language well. The instruct series is pretty much the same, but it does even well with instructions. And then there's CodeX, which is very good at translating language to code. And there are some parameters that you choose when you go to this interface. And temperature is kind of how creative you allow the machine to be, and the response length as well, how many characters should be in the response. And the stop sequence is after what sequence of characters should the response of the machine stop. And there are several other ones, but we will not look at them today. And so the first task that I'm giving it is ask it to add a unit test. So what you see here is how I'm interacting with the machine. So the input that I'm giving it is just this set of code and this line that says add a unit test to this Go code. And this is all the context the machine gets. This is nothing beyond than that. So I'm just running, and let's see what we hope that will happen. So the input that I gave is a part of a library, and probably by now you got more context than the machine did. And I expected to get from this set of combination of a library and the function to give me the output, which is my command. So it successfully understands the context, it successfully understands which library, which language, it understands where the code ends and where begins the code, and where to, and it does the output. Wow, that's faster than me. So next example. Next example is I'm asking the machine to explain in detail a piece of code. So what happened is that I highlight this piece of code that I got from an open GitHub repo. It happens to be Prometheus, which I find to be a wonderful tool for monitoring and logging. And I just copy it and I drop it back into this screen together with the instruction. And that's pretty much it. That's all the context the machine gets. So it doesn't know, again, the language. It doesn't really know the library name. It doesn't know anything. Let's see if it can help me understand what is happening. And from the output, you can see that it not only understood what it wants, what I want from it, but it also successfully performed the task that I asked it to perform. The next task that I will ask it to do for me, now I want it to do next, and again next. All right. So here, I want it to help me understand a little bit of Bash or awk specifically. So I have downloaded this library, which is this data set, which is a CSV from Kaggle, and it just has a list of songs. And I want to filter this list of songs to just give me some recommendations of songs that I can use, for example, in my working hours. So I see the format of the CSV because I did head, and I see that it has an artist name, track name, and playlist name. So I'm going to ask for it to focus, to filter by words like deep and focus, because I assume it will help me find songs that are good for working. But I want it to only print the fourth, the second, and the third. So that's the order of the columns that I want. And I only want 12 rows. Now, that's a kind of complicated regex/awk command, but I just wrote the comments, and based on that, it successfully generated for me a command. Don't trust me if it's good or not. Let's actually run this one. So I just copy-pasted it from the output, and let's see if it did, and it successfully filtered for me playlists with the name Deep Cut, and these are names of artists and names of songs. So the command is correct, and it understood what I wanted to do from this set of comments that you see here. And it even did that from the first attempt. Let me tell you, as a developer, I would have not succeeded doing this in the first attempt. It's worth mentioning that also in the previous ones, performed probably faster than I would perform as a developer, just getting the context and so on, and also getting things right. So the last thing that we see here is I am a backend developer. I do lots of DevOps. I do lots of infrastructure. I am a terrible front-end developer. But I want to build myself a website. So I'm giving in the commands, build me a website where the landing page says this. And this is the contact button that should show to this email. And please include this cat image and also add the list titled resources with 5 websites of online courses like Coursera, which is a little bit vague. And I intentionally do this a little bit vague for the purpose of showing how powerful and smart this machine is. Like if this is a Jira ticket, this might be already making some mistakes. But I just gave it comments, it generated something, I am highlighting it, and I'm dropping it into Replit, which is an online editor, because I want to quickly see how good will it build my website. So I'm just doing copy, paste, and run. 0 setup, 0 work. And look at that. This is my website. It has the title that I want. It has this contact me button that you see it leads to the email that I wanted it to lead. It has the picture of the cat that I wanted. And it generated this list for me. And the list is 5 items of educational websites like Coursera. And indeed, Udemy and Udacity and so on, they're good resources for learning. That is pretty wonderful. It built me a website with just a few commands. So at this point, I will jump back to the slides. And I will remind you that if you have some curiosity about fun things that I've been doing with CodeX and other AI engines, really, you are very welcome to follow me on YouTube. I will be sharing the link to my YouTube on this channel, on my Twitter handle, because YouTube URLs, I guess, are always longer than Twitter handles. And I sometimes get all sorts of interesting questions like, can you do this? Can you do that? How would it look doing this? So we can experiment together. It's a pretty powerful machine, and it's very nice to be able to just share it publicly with everyone as part of this privilege of being an OpenAI ambassador for developers. So the introduction of AI engines also introduced a new type of engineering, which is called prompt engineering. And prompt engineering is a lot about the way that you phrase your request or question to the machine, because it has been trained on the large chunk of the internet, but it has not been trained in the same English level as you are. And I'm not native in English, as you can hear. So my way of interacting with the model would not be the same as my American colleague interaction with the model, which will not be the same as my British colleague interaction with the model, and not the same as my colleagues in India or anywhere around the world. So learning to ask things in the computer language is this fun thing of prompt engineering, and it's giving correct context while also being mindful of the total number of characters or tokens in the screen, because there is a limit to that as well. So AI generated code and focusing on Go. So let's talk a little bit about why Go. It's not just a very useful and practical language for writing backend code. It's also a wonderful language for infrastructure for many reasons. For example, you can create the binary and cross-compile that to any environment with just one flag. And this binary file will have all the dependencies inside. So you have this few lines of shell, and you have everything in one place that you can just drop all the version updates everywhere. A lot of the modern tooling is written, of infrastructure is written in Go, like Kubernetes, like Docker, like Prometheus, like Jaeger, and many others. And one of the bigger reasons for this is that infrastructure is no longer just a set of scripts that you just patch and call it version 1, version 2, version 3 final, version 3 final 1, but you actually have to start managing configurations in a very careful way, and you have to manage the versioning of the code and of the tooling itself in a very careful way. Go is written with concurrency and with parallelism in mind. And I think it's a great choice for any DevOps and infrastructure work that you'll do, including with machine learning ops, of course. So CodeX supports multiple programming languages. Python is the one that it would perform best in, but Go is also very high on this list. Now, here's an interesting thing. When you look at small code snippets, you cannot really tell which one was human-generated and which one was machine-generated. But, and I'm not talking just about a hello world, I'm talking about complex commands, right? there is a name of a client. So I'm giving the instruction, use it correctly to utilize its functionality. Now, as a developer that is using a new library, I will need time to figure out what does it do, how do you do things with it, see some examples, browse some docs, make some mistakes. CodeX, on the other hand, says not a problem, goes ahead, imports the library that I mentioned, even not by the exact name, adds any additional required libraries, and writes the code correctly using those libraries. So it already performs better than me as a developer in some tasks. It also does exactly all those steps that I asked it to do, and it even adds documentation. And the fact that the code is written the Go way, it leads to the fact that if I told you that I wrote this code, you would believe me as much as I told you that the machine wrote this code. But this is not always the case, especially not if we're talking about generating a lot of code. Because code can look like machine generated, and this will land us in the uncanny valley of code. The uncanny valley is a concept that was identified by the robotics professor Masahiro Mori in 1970. This is a hypothesized relationship between an object's degree of resemblance to a human being and the emotional response to the object. Basically, if it looks very far from human, it's nice. If it looks awkwardly like human, you feel uncomfortable. But if you cannot tell if it's human or code again, you're feeling good. And that's wonderful because Go code that we know and love is already auto-generated with GoFunt. So we're actually expecting it to be rather robotic. So you are safe with the uncanny valley of code if you write it with Go. Some additional good things with Go is that there's one clear way of doing things. So you cannot be trapped in different paradigms that will make it not fitting with other code. And with the inevitability increasing automation, you will have to read more new code because a lot more of it will be auto-generated. So us developers need to parse quickly, and we kind of become this little compilers. And Go simplicity helps a lot to us by providing this readability. And GoFunt parses the code into a syntax tree and stores it instead of the source code because all of the Go code has the similar outputter. Another machine can have easier time replicating and creating this output. So what is next? Don't put down the keyboard and leave just yet. Instead, hop on the early train and embrace the future. I see it to be no code and AI-generated code. What is there to embrace? Well, we'll skip the examples because we said you can see them on YouTube and in many other places. And there's lots of wonderful examples online and even on the GitHub Copilot page itself. Instead of automating the repetitive part, we get to have the boring part automated and do more of what we enjoy doing. For example, testing. Any repetitive code snippets like types? Wonderful. You can automate. Not sure how to solve a new problem? Well, you can ask your colleague, you can Google, or you can get inspired by some autocomplete suggestions. And you don't have to wait for the peer review to see some more ideas of solving a specific problem. You can already ask the machine for some alternatives code for how you wrote this code. Automate comments. Now, this point easily deserves a whole talk, but I will settle for showing you some interesting answers that I got when I asked about this on Twitter. So people don't document enough, and they are aware that this will slow us all down. AI engines that specialize in code and are able to document better and understand better will help us jump over that. Speaking of understanding code better, this is another thing that you can do. Just drop code to it and say, as we saw in the video example, explain to me what this code does. So my prediction, AI-generated code will change software development. Backend, front-end, mobile games, we saw that all those languages are already supported by CodeX. Data engineering, now that's an interesting thing. It's more than instructions that is still needed, but the execution does get more automated increasingly. We can summarize with this point that AI will change development as we know it. Now, code generation and no code will become part of every development flow. In the same way that an IDE makes your development faster by, for example, showing you the function signature and other useful info, all the benefits of AI-driven development that we covered will be just part of your IDE and also your developer flow. Even more than that, No code is now becoming generally available. This means that more people are able to create. So all those tasks that you don't really like add this button for me or make it larger, smaller, or blue, are being offloaded from the classical software developer to the no-code software developer, or as we like calling it, creator. This does not only mean that you are being pushed out of job, actually, not at all. This means that you can put more effort into things that you might enjoy more, like algorithms, and instead you get to democratize code for everybody and by a backend developer, for example, who is integrating some no-code tooling into your backend. You are enabling your colleagues to do more and contribute to the development flow. I am a great believer in this mission. This is why I joined Entor. Please join the waitlist if you want to try it. So there's a lot more data collected and used for recommendations, personalization, and so on. All the fields will be more AI-driven. I mean, have you heard of legal tech, agri-tech? AI will not skip any field. So everyone has a lot more data, and the code that is processing it is getting augmented. How about how it runs? Sure, there's cloud solutions like Azure OpenAI Service, but with any cloud solution, it's not always the right choice. Plus, somebody needs to maintain that. Now, infrastructure and monitoring already have a lot of automation in place, which will not go away. But you cannot ask a model to just autocomplete configurations for you. What I can imagine is more efficient set of default values, for example, based on your specific use case, but this is not something to blindly take to production, at least not in the foreseeable future. It's like that CodeX examples that it can generate an SSH key for you, and it will be in the right format. It's just not going to be useful, and it's definitely not going to be yours. So MLOps is a set of practices that aims to deploy and maintain machine learning models in production reliably and efficiently. If you will browse some of my talks in the past, you might see this article and this diagram. And you see that black square in the middle? This is the percent of the code that is used for the machine learning model. About 5% of the production code is actually used for the model itself. The rest is the supporting infrastructure, serving, monitoring, security, features, data collection, and whatnot. And indeed, MLOps and AIOps is an increasing point of interest. Although the name split between AI and ML migrates here as well. It's a little bit funny to see the separation. And good thing that Go is a wonderful choice for both infrastructure and ops. So the last point for my prediction is security. I expect it to be similar to AI in chess. It will take time for machines to outsmart us, but eventually it will be able to do more things than us, just try more ways of hacking than us. And then maybe all that's left for us hackers is just social engineering. But that is for another conference. So what can you do today? Apply to get access to the different AI engines, like the CodeX waitlist. OpenAI's GPT is already generally available, and Copilot is on the waitlist, and several others. Practice machine learning ops. You already do some infra and ops with Docker, Kubernetes, and setting monitoring and so on. Well, now AI is entering in all the different biz logics. Learn how ops that is relevant to support AI and ML can be useful for you with things like feature stores and whatnot. Even better, next time that you're looking for something to hack, try to build a basic end-to-end machine learning infra. I gave some talks and workshops about this, and there are some examples that you can already try yourself. Integrate automation, AI, and no-code into your flow. For example, GitHub's Copilot, for example, Entor's no-code enablement. And, of course, be excellent to each other. Your fellow human developers will stick around for a while. So a quick recap of what we saw today. We talked of a brief history of AI and the current state of things. We talked about AI-generated code in Go and why Go makes a wonderful choice for this. And what's next? How can you automate and support AI-driven development and no code in your production system? So thanks for coming to this talk. I hope you learned something new. I hope this inspired you to try something. And please tweet and share anything fun that you might have seen.
Natalie, thank you so much for your session. It was really amazing and very good insights. And thanks also for the predictions. I think can agree with a lot of them, if not with all. There are a couple of questions about Go, MLOps, and so on. So I would say that we just jump in, okay?
Sounds great.
Perfect. Okay, there is one very specific question from Lean. He's asking, or she's asking, can you do memory management with Go?
Yes, you can dive into that as much as you want, but there are some good things you can do with it. And there's also lots of good talks that explain that in a lot more detail than my answer.
Okay, thanks for the answer. Then Paul is asking if you have tried out Rust personally for yourself.
A long time ago. It has changed since. So I'm not up to date with how Rust is today, but I know Rust has lots of wonderful things you can do. Haskell has a lot of wonderful things you can do. How does it, if the following question might be, how does that work for the AI? I can say that this has not been trained, specifically CodeX has not been trained as much on those. So it will be better, is my answer to this predicted future question.
Okay, perfect. I assumed that as well. Then one question from David. He's asking data-centric or model-centric AI. Maybe you could have elaborate a bit on that, when to use what.
Can you focus that for me? Like what?
The comment or the question just says data-centric or model-centric AI, but David, maybe you can specify your question a bit more, or tell us what you really want to know, and then we'll forward the question.
Then we can make a talk from that as well.
Yeah, I think it could fill up a whole session. Then Greg is asking, are there any good AI-driven libraries for fuzzing or auto-generated testing? And also there was a question from Julia. She's also saying that we speak a lot about AI code generation, but is there an AI for testing or security? Or let me make the question even more complicated. Is maybe the auto-generated code already tested and doesn't need testing?
Yes, security is very interesting. Fuzzing is very interesting. So I'll try to answer everything and tell me if I missed anything. I am not aware of any libraries at the moment that use AI for the purpose of fuzzing things, but Go has wonderful support for fuzzing. Also, lots of great talks about that. I absolutely recommend just Googling Go fuzzing and catch up with the most recent content. Don't go to content from 2 years ago because a lot has changed since then, unless you're curious about the history, and then go do that. There has been at least one scientific article on is AI generated code secure or not. It specifically looked at Python and C, I want to say, maybe at some other languages, and it came to the conclusion that it's not really following some of the best practices. And so you can create a library that will give code as an input, and you will kind of ask it, is this secure or not? I think this does not exist yet. I think this might be useful to have, even if you cannot rely on it blindly. It can be a good kind of crutch to use. AI generated code has been trained on open source code. Open source code is obviously less reviewed than closed source code, let's say. Just because we work in companies, many of us have companies that have like a closed source as policy, and then you would review each other's code, and this will all stay private, and GPT or CodeX has never seen that. But if you go to some hackathon and just quickly like hack something, upload this to GitHub, and then it's open source, good chance it has been trained on that. And your best practices are not in place. They're in place. So my best practices, not best practices, are also there in place. So it will not always create the most efficient and secure code, and there's a lot of work to be done there as well. If anybody is looking for an idea for a startup, so you're all onto something very interesting. Definitely, it's the beginning, and there's a lot of place to improve.
But obviously, like when we contribute to open source projects, then we could also basically help to, make more or make the AI generated code more secure, because right. Okay. And
yes, we like helping put good quality open source code, for example, being secure, for example, being tested, for example, being documented, will help the machines learn what we want them to do.
Good to know. So you heard it. Then next question. Let me see. Why is it important to track data provenance and line it?
To track data what?
Data provenance. Not sure how to pronounce it correctly.
I apologize, I'm not sure. I'm going to quickly Google that because that's what we do online. Metadata that is paired with records that detail the origin, changes, and supporting information done to data analytics process. So basically the question is, why is it important to have metadata to the data? So it looks to me like it's what I sometimes call data governance, right? So basically keep track of what changes were in your data. And I assume this means in the context of data that is used to train models. The reason that you absolutely have to do those things and keep track of, like versioning even your data similarly to how you version your code, is, for example, you train your model on some data. And that data is given to you by your clients. One of your clients is leaving and says, please delete all of my data from your system. That also means you have to delete all the data that was used to train the model. So this is one reason that you want to have that version, so you can easily roll back to a version where they will train the model on data that does not include the data of that specific client. And if you don't keep this analytics and tracking of this all sorts of metadata, it will be a lot harder.
Okay, thank you very much. And one more general question about MLOps in general. Can you talk a bit about or say something about metrics and monitoring or something in this direction?
Absolutely. You should keep track of many different things in a regular infrastructure system, right? Like how many connections to the database, how many timeouts, how many users are connected. This will help you kind of avoid bottlenecks and make sure your system is generally functioning. And then if you have MLOps system, so one that runs a model and serves and maybe monitors the performance and maybe kind of gets like feedback loops and so on, you have to check for so many more things like, is the business logic met? For example, you work at a fintech company and your product is a model that says, is this a fraud or not? So it's very easy to say, everything is fraud. You will be 100% correct, but you will quickly run out of money for business logic reasons. So you have to see, for example, one of the monitoring that you would put in place is that does the performance of your model make sense, not just on the technical side, but kind of on the user's side. You want to make sure that you, for example, you have another model that does recommendations. You want to see that a high enough % of the users accept these recommendations and would actually click on you might be interested in. You also want to make sure that there's not too much coupling going on between different models that you have in the system. I can go on a lot about this. This article that I mentioned with this graph of the 5% of the machine learning model talks about a lot of the things that you should have in consideration in case you have an MLOps system in place.
Okay, Natalie, thank you so much. And just by the way, for everyone watching us and interested about fuzzing, Wojtek has put in the chat a link to a GitHub project, OSS Fuzz from Google. It's a continuous fuzzing for open source software. So everyone who's interested, please check it out. And Natalie, we are already over time, but time flies when you talk because it's really super interesting. A lot of thank you so much again.
Thank you very much.
I hope to see you soon again at another event, maybe with another topic. I think there is like so much space to talk about AI and what it means for software developers in general. So thanks for being our guest today. And,
thank you.
Wish you a nice rest of the day.
You too.
Bye. Okay, we are going to a very quick and short break, just 5 minutes, and then we are back with our next session. Hello and welcome back to our next session. Our next speaker is Martin. He has already been once a speaker at WeAreDevelopers last year, and today he has a new topic. He's a DevOps engineer at Ackee. For the last couple of years, he worked on cloud solutions, and he has a passion for implementing procedures and speed up development processes, which is basically a perfect topic for the DevOps Day, as this is all about it. So please welcome Martin.
Oh, thank you.
How are you doing?
I'm doing all right. Thank you for asking. How are you?
Yeah, good. Good to know. Before we start, do you want to give us a short sneak peek what your presentation will be about?
Oh, it's going to be, about SRE business, how we do it, and how it's different in an agency environment. So I think that's like a main topic I want to make.
Very interesting. So I would say the stage is yours, and we will see each other in the Q&A session.
Okay. Thank you very much. Thank you for the introduction. And as it was said, my name is Martin. I'm going to talk about SRE methods in an agency environment. So I'm really glad to be here again online. So first of all, I would like to talk about keywords. And those are the keywords all of us might know. But again, I'm going to repeat those because there might be some misconceptions. So to make a summary, it would be, let's say, better for all of us. So we basically have these three keywords. One of them is SLI, which is service level indicator, which is, for example, availability, latency, error rate. It depends. Then we have SLO, which is service level objectives, and the only addition to SLA is that there has to be somewhat a threshold. Availability in time shouldn't go above or below. Latency shouldn't be that bad or that good, or error rate shouldn't go above something. And then we have SLI, which is basically SLO with the addition of giving penalty for going over given threshold. So that might be an availability in time with a penalty of few bucks if you do not keep up with given threshold per month. So now when we established what we are going to talk about, I might thought that this relationship of agency, customer, and clients might be a bit difficult to grasp. So that's why I've prepared this few slides just to introduce. So basically, customer orders an application for his clients. Okay, that works. Agency creates the application for the customer. And for that, I've prepared some small UML chart. It's going to be really simple. You don't need to really understand that much of UML. So it's basically this. So here we have clients, and then we have customer who wants an app. So he goes to the agency. Agency will think about it and consider all the facts, and at the end probably say, okay, yeah, we can create an application and just give it to you. And at the end, clients are really happy that the application is going to be done for them and prepared. So just to give these actors some names, we actually created an application for Bundestag. So for us, the Bundestag was a customer, Ackee is an agency, and the clients are the citizens of Germany, hopefully happy with our application. So how does this really work in context of SLA and SLO? Well, SLA gives an insights for the customer. Those are basically indicators that show what system parts play important roles and how are the parties are going to monitor those and keep an eye on them. Defining SLO makes customer and agency understand the responsibilities, especially if the assets are kind of shared, meaning that you have multiple API endpoints, and you just want all of these parties understand their thresholds and how they should treat their responsibilities. Of course, showing SLA to the clients make up trustworthy. And this is just for example. We all love this feeling when something is going down and it's down for a while, and then we can just ask for credits, So that's a lovely feeling we all like to have, and that's for what SLA is. But wait, customer might say, we don't need an SLA from you. You're just an agency, so just prepare an application for us and we can just all move on. Project managers might say, wait, is that even agile? How this, whole SLA, SLO really fits in our, sprints and our development cycles? How does it even work? Agency itself might say, what reliability? We are an agency, meaning they are there just to prepare some minimum viable product. Customers say, oh, well, never mind, we will scratch that after handover. And developers, and they usually do that, well, what a waste of time. And that's usually the place where I come in. So as it was said, my name is Martin. I do not really like to introduce myself, so this is going to be really fast. If you are interested, just check my LinkedIn. I work as an DevOps engineer in Ackee. I like Python, Kubernetes, serverless. I also love beer. Yes, I'm from Prague, Czech Republic, so that's kind of default around here. And a few words about Ackee. As I've mentioned multiple times, we are an agency, somewhat a software house. So customers go to us, give us their user stories, and based on their description and use cases, we just prepare the applications for them. We like to think about ourselves that we are agile, fast-changing company. Who isn't these days? We like to standardize a lot, which kind of helps us to make a way for fast changes. And of course, there is quality sentiment for operations. Just to give you a hint, it's like a 3 DevOps guys to manage tens of projects and help to other 70 employees of Ackee. Also, Ackee is in Jamaican fruit. So if you are interested and you are going to Google us later, just be prepared to scroll a bit. You are not going to scroll that far away in Google search, but we are just competing with the fruit on Google search. So that's a lot. And about that Bundestag app, I wasn't really kidding. So if you are interested and are from Germany, just go check it out and let me know if that was something helpful and you enjoyed it. I never use it. I do not have a use case for that. So it apparently won some awards. So I would guess it's a good app. So yeah. And with that, we can just continue from a boring introduction into the real presentation. So what are we going to talk about today? Well, we'll talk about creating SLO documentation. We'll talk about the handover scenarios, which are kind of important, especially for agency. We'll talk about the importance of documentation because at any conference, there has to be a guy who will spend at least 10 minutes describing how documentation is important. So today, that's going to be me. Then we'll talk about unexpected cost, and then we'll talk about the handover itself. So what does it mean when I say, well, creating an SLO documentation with customer? Well, first of all, I would like to say that you should be always careful. Customers might have some ideas which are a bit unrealistic. The expectation might be higher than needed, usually higher than required. And creating an SLO document is a process. So that's why I was so happy to find this this picture of ants going in circles. So let's just try it on example. What's the highest allowed latency? What's the highest allowed latency our application can afford without hurting user experience? And before you introduce your application into the production, you kind of have to play the guessing game. You can create your synthetic clients, prepare some user scenarios based on the expected behavior, which is kind of tricky, but out of the tools you can have, this is the only few you can use. And then you just benchmark the app, get some numbers, and prepare your thresholds based on those. Situation is getting better and closer you are getting to the production period. So before that, you usually have some limited availability period where you have some statistically insignificant number of users. It depends. And again, in that case, your numbers are going to be, statistically unreliable, let's say. Just to give you a hint, first users might be biased, and this kind of goes in both ways, both positive and negative. They might be expecting a lot and just do not give that much care to some possible issues, or they just might not expect anything and just write some really bad review just because they can. So that's a thing you have to consider. I'm not going to give you like the definite answer, like how should you do it? How should you prepare your threshold before the production runtime? The only point I'm going to take is that evaluation of SLO documents should be done periodically. You should always keep your estimates rational, and one of the rules you have to follow is that if you exhaust your error budget each month, this is just wrong. And error budget is just a difference between the whole time minus the given SLO. So let's say your availability is designed to be 99.99% in a month. So that kind of gives you only 4 minutes and 22 seconds in your error budget. So if you go over these 4 minutes and 22 seconds each month, you've probably done it wrong, and you should really think about if your process is just good enough, and how should you change it. The thing is that the content of SLO document should be agreed upon before production release and the handover to the customer. Those are the main 2 points we kind of have in an agency before we kind of have something we can provide as an SLO document. So now when we know the points where this SLO document should be ready, let's just describe what's happening if you are giving the application to the customer. So for that, I've defined 2 scenarios, the conditions of surrender. And the first scenario is quite clear. Customer has the capacity to take over. In that case, your documentation is the key, and the knowledge silo is an adoption risk, meaning that if you forget to write down something, you are going to pay with your time in the future, because you'll have to add your descriptions in some correct documents and so on. So it's going to take a while. So understanding and recognizing those knowledge silos may help you to, let's say, make the adoptions period much smaller. SLO document has a description value to the customer, meaning after he's going to get the application, he might spend some time on customizing whole thresholds, preparing them for their own workflow and their own SR regime, and kind of adapting everything to their own needs they are kind of used to. And the second scenario is that customer does not want to maintain the application, but is strongly interested in the reliability of an app. In that case, application is your responsibility, meaning if you are an agency, you have to take care of this, and we cannot do this as well. Not that many times we would like to, but we can do that for our customers. And in that case, SLO document is a commitment value to the customer, because in case the threshold is going to be reached and it's going to happen quite a while, he's going to hold you responsible for that, and it kind of makes sense in that way. So regardless of the scenarios, documents are always important, obviously. So just to illustrate my point, if nothing is happening, customer might say, oh, we don't need an SLO. We are all expecting 100% availability. That's a bold statement. Not even Google is, that sure that he's going to provide 100% availability. So that's kind of hard. In case something is happening, agencies might say, okay, what? We never promised to be online all the time, which is, again, something which shouldn't really be claimed, especially during production runtime. These statements should be, agreed upon or removed right before any production is going to happen. And once everything is done, everything is working correctly, if only there was a document explaining what happened last time, because usually after a while people just tend to forget something was happening, and if something is happening again, they just have to work on it like it was a new thing. So for that, we kind of estimated these 3 important documents, like the holy trinity of the documents we provide with our projects. Suggested by years of mishaps and misunderstandings, we came up with a SLO document. We already talked about it in a bit. Then we have support playbooks. They are just a description of support actions we are going to take once the SLO is in danger. And then we have postmortems, which are really lovely. I'm going to talk about them a bit. And they are just an incident documentation, like what happened and how it was handled and so on. These 3 documents kind of work in between each other. If you have SLO document, you have some thresholds which are to follow, and they are really agreed upon. Everybody understands them. If you have support playbooks, they are just describing how are you going to keep up with your SLO, what are the actions taken if something is happening, and so on. And the postmortems are, let's say, like a retrospective of all these 2 before, So how did we actually settle the incident? Were there any actions which needed to be done after the incident is resolved? And if there is like any chance this is going to happen again. As I said, I really like to browse postmortems. That's just, the part of my cynical personality, which really likes to read all the bad things that happened, and just to give it a few smiles and so on, just to remember how horrible it was. So I kind of thought that I'm going to give you a little example of postmortem. We are not going to do a postmortem of this house. It's done. I'm not sure how it happened, but it's gone. So first of all, if you are writing postmortems, be detailed. Usually write your postmortems like day or 2 after the incident is resolved, because your memory is kind of fresh and you kind of have all these bad feelings, in your mind, and you can just correctly put them into your documentation. Be blameless. Even though it would be nice to blame somebody, it's not really contributing to information value of the document. So, just imagine you are going to read this after months and months, and you probably do not even remember who you were blaming for something. So it doesn't really make any sense to do that. And always fill out following items. What was the impact? What was the impact on the customer and the client? Meaning the client wasn't really able to, let's say, change the password, change his picture in the profile page, and so on. What was the root cause? And this is the impact on your infrastructure, let's say. So what was the absolute root cause of the incident? Meaning you misconfigured something and your database went offline. Your application servers went down because of some reasons, and so on. What was the resolution? What were the actions taken to remove the incident, and how it was dealt with, and so on. And then we have action items. Those are kind of important because they are describing the actions to avoid the incident in the future. And especially if somebody is going to browse the postmortem after a while, he can easily check if those actions were, done and they are finished. So if you just write the postmortem and forget about it, this is something which might haunt you. So be ready to work on your action items and finish them. And then we have timeline, which is minute by minute timeline of an incident, which are usually really lovely. Here I have, again, an example. You don't really need to read it. The point is that it's kind of long. So long story short, 13 people got involved. Not all of them kind of contributed. They were just not really sure who to inform, who to ask to fix it. So it was like support members, board members, which is kind of funny, board members, how they can actually help during the incident, project managers, front-end developers, a lot of guys, 13 people. It's just a lot. So it took us just an hour to reach a second layer support. Availability went down to 99.88%. We defined SLA as 99.99%, so that kind of gave us like 45 minutes in an error budget. So our budget was like depleted for like multiple times during that incident. All releases were halted in favor of stabilization. So we kind of waited to our budget to populate again, and during that time we work on the stabilization of the application. So we just released fixes and some things we kind of thought that they are going to help us avoid any incident. About that 13 people involved, there was like a key thing really missing. So usually you should have like 3 rows of people who are responsible to manage the incident. You should have your incident commander, who has a total responsibility for an incident. That's a huge role to take. Then you have communications lead. That's usually a guy who periodically informed to predefine given channel. And then you have operations lead. That's usually again DevOps engineer trying to work on the incident. Those communications lead or operations lead, those are the guys who are appointed by incident commander. And once they are appointed, they just couldn't give up their position unless incident commander says so. So in a way, incident commander should be the guy who is, somebody who knows his stuff, and who can, let's say, decide the best in case something wrong is happening. So it's a really tough role and it's really hard to take, but it is, manageable. So for that, I write down again just a few sentences like what should never happen in that scheme of 3 rows. Project manager gives a call to the incident commander to get incident status. Also does not want to hang up. And there are like 2 things in this sentence. First of all, incident commander shouldn't answer any calls because he should work on the incident. So in case there are not like information periodically given in some predefined channel, some people might try to think that they are going to give a call to the incident commander, and for that they are just going to spend valuable time talking about it instead of incident commander fixing the issue. Also, if somebody does not want to hang up and you are on your mobile phone connection, that's just really bad, because usually your phone disconnects and just handle the call by its own. And that's something which really happened to a friend of mine, and he kind of spent like 10 minutes talking with his project manager until he was like able to describe the situation and that the project manager should just hang up. Incident commander spends an hour struggling before appointing operation lead. This is kind of something we have as a common rule. Usually operations leads are the guys who work directly on the project, and incident commander sometimes is not the guy who gets really involved in that project which currently has some kind of incident. So in that case, if the incident commander struggles for like hours, this is really bad. That usually means that the error budget is just already gone, and somebody else should have been like able to fix it much faster. So again, this kind of empathize how important the incident commander is and how much effort he's going to he should give during the incident. Customer informs about the incident in the wrong channel. That's also happening, and the result I've showed you in the example we've seen in the past slides. And communication leads forgets to report periodically, because in that case, we just repeat the cycle and somebody tends to give a call to an incident commander and whole misery just continues. Now, when we talked about the SLO, handover scenarios, and so on, so let's just describe some unexpected work and costs with regards to SLA and handover. So for that, we have 2 types of events. Those are environment events and the security issues. And we kind of always have to think about those in the context of SLA. So what does it mean when I talk about the environment events in this environment? So For us, those are the events we can't really influence, and they are kind of given by the environment, obviously. So that might be a cloud provider, some tools for deployment, and so on. So for that, I've chosen these two examples. First one is that the issue we had last year. We are using GCP quite often, and one day Cloud SQL just decided to completely disable event triggers, which are part of PostgreSQL. And for that, we didn't really have any issue. We just noticed that, reworked our workflow and just moved on. But others were not that lucky, So you can just go into that issue and read it by yourself. And some of the people were really upset. They were just generally considering to move to AWS at that point. I can't really blame them. If your workflow is entirely based on those features and somebody just decides to switch them off, that's a huge deal breaker. So once I'm trying to throw dirt on GCP, I should do the same at AWS. And for that, I'm kind of lucky because we have Corey Quinn, who is like a professional hater of AWS. I strongly suggest to follow him, but he tweets a lot, so be prepared for that. So apparently it costs 3 times more to download 1 terabyte from AWS Cloud than it does to buy and have Amazon ship you an empty 1 terabyte hard drive. Yeah, that's the reality nowadays. So you kind of have to work with this scenario and keep that in mind if you are using AWS. So generally, environment events are really hard to avoid. They have to be accounted for, even though you might do not know like how much money it will take to mitigate those. And usually they are better accepted once the customer understands the use tooling and the customer is proactively informed, meaning that he understands what's going to happen and how much work it's going to cost him. And for both of those clouds, like for the majority of the cases, I have to say that they are really doing a good job by telling people like what is going to happen, when it's going to change, and so on. So the second type of unexpected costs we are usually encountering is security issues. So just a little example with an NPM audit. That's a thing we have in our pipelines, and it usually runs with every pipeline we execute. So in here we can see that there are like low severity issues, 180 moderate, then high. That seems like a important information and something we should work on. All of this could be like assessed in case of like a error budget policy. So the possible impact should be evaluated with regards to SLO. And for that, we have this error budget policy where we defined thresholds, which kind of say what's the importance of the danger to the SLO. So in here we can see like 3 thresholds. There could be more or even less. First of them is just the impact to the SLO is insignificant. Change can happen without further escalation. Those might be like low severity issues from NPM audit. And up to the third threshold where the impact to the error budget is significant. And in that case, somebody responsible should be notified, executive board, project managers, and so on. So with regards to the NPM audit, the issue severity and how it should be mapped to the budget policy. Well, if you have a high severity, the error budget policy impact is high and customers should be informed. And on the other hand, low severity says that impact to error budget policy is low, and you should consider if the impact to the development should be, high or low. It depends on the severity, on the type of the issue, and so on. So this should be usually evaluated by the developers themselves, and they can kind of decide if that is something we should spare time on. So now when we discussed the cost, the importance of documents, documentation, the handover, we'll talk about the handover itself. So what does it really mean for us? So we usually, share the stuff we have. Those are credentials, SRE documentation, tooling, obviously, and then we have like a short adoption period where we discuss all the things with customers' SRE team, and we try to give them our knowledge for them to compete with the possible incidents in the future. So once we are talking about the credentials and how to give them to the customer, we kind of have like two types. Here we have like a user credentials, and those kind of different for the clouds we use. For GCP, this is kind of easier because you do not have any like an identity folder. You are just assigning roles to the users, and those users are identified by their email. So if they can just prove that the email belongs to them, they can authenticate with it and be authorized to use the roles you assign to them. So once you are done, you can just remove those assignments and have your own project without the agency involvement. For AWS, this might get a bit tricky because AWS actually has their identity folder. So you should usually browse the identities. Just the best practice would be just to rotate the credentials or just disable the users which shouldn't be part of the project. So after you are like done with auditing your users, also check your roles. And for both of those clouds, you usually have wonderful tools to do that. So this is the example from GCP. And here you can see that last time the role was analyzed, only like 8 permissions are used often. The others are just the access permissions, and they should be removed from the role, and nothing bad is going to happen. So this is something before you transfer the project to the customer, and it's kind of the project hardening. You are making your application much secure like that. And then we have like an application secrets. For that, I would say that we usually consider like cloud secret managers. Those are like AWS secret manager, GCP secret manager. It depends on the project, and both of them are really good tools. I think they were like introduced last year or year before that. So they are really practical in the sense that if you are going to give away a whole project, you are just giving it away with a secret manager as well. We also tried using HashiCorp Vault, which is a wonderful tool. The thing is that you kind of have to manage it by your own. So that means that you either have like a lot of instances you should update here and there, or you have just one instance and you just give credentials to the customers to log in there, which is kind of impractical in a way that the customers had to rotate their credentials once in a while. So it's kind of hard, And just a note, CR variables are not really practical in that case because, CR variables are there just for CI. So you are not really helping yourself. You are just putting there some secrets in there. So now let's discuss a bit the support documents and what should be really there in case you are handing over the project itself. So apparently you should give away this Holy Trinity we have, like the Ocello documentation, support playbooks, and postmortems. Those are the 3 documents I described a bit before. And one other thing is that you should be always sure that the channel you are choosing for sharing those documents should be like well managed by both parties. We usually like to use Git for all of our documentation, and it kind of takes us a lot of time in case the customer is not really Git friendly, especially for documentation. So it would be like a speed up if you discuss that with the customer well before you are starting to work on anything written. And just the customer can choose if he is like more familiar with Google Drive, Atlassian, Confluence, and so on. And the other thing is tooling, And for an agency, tools are on a different level, meaning that agency might have adjusted their tools to serve repetitive tasks. And this is not something new. That's what all DevOps people do. We kind of do it on a different level. We are like automatizing like from a project creation to let's say, support management, and so on. So there are a lot of things which are kind of neat if you are doing a lot of projects at once, or you are just moving from one project to the other really fast, but they are not really useful for the customer himself. So we kind of take the time and remove some tools which are not really important for the customer, and we also take the time to explain the usage of those tools if the customer is kind of involved and he kind of wants them to use it as well. And then we have like an adoption period. That's the time we usually sit with the customer's study team. We kind of browse through the postmortems we had. We explain the situation we had. And like one serious note, and I already talked a bit about it before, is that if you just browsing postmortems with the customer, just be prepared and finish all the action items you kind of wrote there during the time you wrote the postmortem, because it's kind of ugly when you just go through the action items and you see, this I kind of forgot to do. So it's not really a good thing to to show to your customer. So this explanation, there should be as practical as possible. So we kind of go through the support playbooks and show how the support playbooks kind of adjusted themselves after the incident got resolved. So it kind of gives us a connection with the action items and how well we handle it. Of course, never forget the common goal. So with that, I would like to do a small summary of the things we talked about in here. So basically, my feeling today, and I hope this is going to change in the future, is that everybody kind of underestimates SRE. It's a bit hard to grasp, so be prepared to explain a lot, not only to the agency, to the project managers, but the customers himself. You kind of should give them some examples, because as I was trying to say, if nothing is happening, nobody is even going to notice you. If in case something is going to happen, you are going to be blamed for absolutely everything. So if you describe your role correctly, you can then just profit out of it in the future. Don't focus entirely on the methodology, even though I've described a lot about it, because at the end, our focus should be the application, and moreover, like the user experience, customer and the clients are going to have once they are using. So basically, user experience is the king, and that's the main point all these SLA, SLO, and SLI are trying to take. So I see that I was really fast. Thank you very much for your time. Hopefully you enjoyed, and hopefully you'll find out something interesting out of my talk. If you are interested in the content we used, like for creating our SRE workflow, for preparing our tools and so on, I strongly suggest you to read the book Google SRE Workbook, which is from Google, and also Satral with engineering, also from Google. There's like a lot of use cases, lot of examples, and so on. If you find out that the pictures are kind of fine, kind of nice, they are like from my friends. And if you do not want to Google Ackee and scroll a bit, just go to the Ackee.agency and you will find out more. So yes, that was my talk. Hopefully you enjoy it. I guess I was kind of fast. So yeah.
Hi, Martin. Thanks for the presentation. Perfectly on time. And thanks for the presentation. It's a really important topic, especially for agencies where you could have the feeling that maybe in agencies like the topic is not that, important, as you gave some examples, what people would say in the beginning of the presentation. So good to hear that there is something there as well. We do have 3 or 4 questions, so
Nice.
let me see how to start. Yeah, Mike has an interesting question, as I think. He's asking, does it happen that you cannot agree with a customer on the SLA and the project gets lost, and how to handle the negotiations or the situation?
That's that's a good question. Usually when we are working on SLA, it means that the application is more or less in a stage of pre-production release. So we, in that point, actually understand the customer quite a lot. We are usually by the time really friendly. So it shouldn't kind of happen that we kind of misunderstood each other's. We are also like trying always to empathize. What does it really mean? That's the main point. So in case somebody is not really understanding and saying that the SLA is just wrong or something, we may be provided like not enough information. So we kind of tend to go into the details and try to describe the situation to the people who are like interested. And in case we find out that even us were like misunderstanding the issue, we can just adjust the SLA as well. It's just a matter of communication.
Okay, so basically you're saying that you agree on the SLA more towards the end of the project before going to production and so.
Well, it should be agreed upon well before that, and we should have some kind of idea that should be there. And I'm just trying to say that in case the customer is not really agreeing upon the given threshold or the penalty, if we are talking about the SLA, something was wrong well before that point. We probably misunderstood our point or the way we kind of work or something like that.
Yeah, that's a good point. That's a good point. Then Julia is asking, are there useful templates that you could recommend, for example, with best practice metrics? I mean, you've guided through the presentation and said like, like this should be included and this is important, why it's important and so on. Is there some kind of standard for SLAs or is there some, you know what I mean?
Good question. I was struggling with that quite a lot, and that's why I was like reading the books I've showed at the end. So basically, if you have the time, just go to the Google Books. They are publicly available. They are kind of huge. I think like 500 pages each. Not really sure now, but you will find almost everything in there, like the templates for SLA, how to write and postmortems. They are really thorough and detailed, and the good part is that there are some like cases from the past and from some other companies who are using the same approach, so we can kind of see that if this approach kind of worked for them or how did they adjusted their workflow because of some different use cases. Because if you compare yourself to the Google, there might be some changes you need to do. So you can kind of see the scope based on the description, and just adjust your workflow based on the past experience. So yeah, my answer is that just go through those books which were mentioned in the resources, and I think you will find out like plenty of your questions you might have answered in there.
Okay, perfect. And then we have a question from Amar who's asking which tool or document used for. Okay, I think he's referring to what tools do you use in your agency for measuring and monitoring the objectives?
Yes. I'm going to repeat myself a bit in here. We are always trying to use the tools the cloud is providing for us because once we provision something, that means we are going to manage it in the future, update it, and keep an eye on it. So for GCP, we utilize Google Cloud Monitoring, which used to be called Stackdriver. It's currently undergoing a lot of changes, so it's kind of hard to keep track, especially if you are trying to monitor GCE instances. So it's kind of tough, but still, it's a good tool, and we can recommend it. And for AWS, you have CloudWatch, which is I think less friendly towards the developers than the Google Cloud Monitoring, but for like estimating threshold, watching over them, and monitoring them, it kind of works. Both of these tools also offer some predictions, like how it like if the metric is going to go above the threshold sooner or later. So I think they are just trying to keep up with the current trends. And for us, if we are going to just give away a project or AWS account, it's like much better to use the tools that are currently in the cloud available. Yeah.
Okay, thanks. So that was the last question already. Martin, thank you so much for joining us today. I hope to have you as a guest in the future as well. And yeah, thanks for the nice overview.
Yeah, thank you very much.
Thank you, and have a nice rest of the day.
Yeah, you too, all of you.
Bye.
Bye.
So very interesting, especially for people working in agencies or running agencies. So we have another break right now, and we are going to be back in 15 minutes with our third session.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello and welcome back to our third session this afternoon. And our next speaker is the CEO of Codiga and also the founder of Codiga, a platform that helps developers write better code faster. And besides being an author, he worked also for Twitter and Amazon Web Services. He improved the infrastructure for elastic book storage, and he holds a PhD and a master's degree in computer science. So please welcome Julien.
Hi, thanks for having me.
Hi, good morning. Just have to check my audio setting here.
Yeah.
Because I don't hear you in my AirPods. So now,
All
hi
right.
again.
Yeah, it should be perfect. It should be good now.
I just heard from backstage that it's 6:30 a.m. in the morning at your place.
Exactly. I woke up really early because, I.
Okay, but every day or just today?
I have to say today I made a special treatment and I woke up a little bit earlier for the presentation. But
Okay.
I got my coffee and I'm ready to go.
Wow, that's amazing. So thank you so much. Thank you so much for doing that and for joining us. So yeah, before we start, would you like to give a short sneak peek in what we are going to learn from you today?
Yeah. So the thing is, I've been an engineer at Twitter and Amazon Web Services, also at the European Space Agency. As you can guess with my accent, I'm from France. And the thing is, I've seen through my career people writing bad code. And the reason I started Codiga is really to try to help developers write better code. So what we're gonna learn today is really how you can automate code reviews, how you can get automatic feedback on your code when you push, when you make a pull request, but also how you can ensure your code quality, how you can make sure that over time your code quality increase, and how you can check that in your CI/CD pipeline. So this is really what the conversation is about today.
Okay, perfect questions, and yeah, looking forward to your answers to them. So yeah, I can only say have fun. The stage is yours. We will see each other after the session again.
Sounds great. Thank you. All right. So today we're going to talk about building a CI/CD pipeline to first check your code quality, but after that also automate your code reviews. So how we can automate the code review anytime you have a pull request, check that you don't have any issue in your in the code you try to submit. So how do you do that? And we're going to talk a little bit before that about the benefit of code review. Why do you do the code review, and why do you want to automate the code review? And you need to also be honest about what part of the code review you can automate and which one you cannot. We're going to talk about how to measure the code quality and how to make sure that the code quality never goes down, actually. Little bit about me. I have a PhD in computer science, actually in France. I live in the US right now for 10 years. I worked at Twitter when I worked in the ads system. So if you see a really good ads on Twitter, that's probably because of me. If you see a bad ads on Twitter, that's maybe also because of me. And I worked at Amazon Web Services, especially on the infrastructure. And I started Codiga to work full-time on Codiga a year ago. And the goal of Codiga is really to help developers write better code faster. So give the tools to developers, give the appropriate tools for developers to find any bug in their code and fix the bugs before your code is deployed in production. So let's talk a little bit about the code quality and code review, and let's focus right now on the code review. Why we are doing code review? The thing is, you have multiple aspects of the code review. The first thing is you want to check that what you wrote is actually doing what you're supposed to do. So there is a part that is checking that the code is in fact implementing your requirement. So that is something that you do most of the time manually. The other thing is you want to check that there is no major issues that are introduced by the change. So there is no security issues, there is no vulnerability, there is no backward compatibility problem. Your new change don't break any existing functionality. You also want to check that the code standards are enforced, because the writing code is really something you do. You write code only few times, but you read code a lot. So you want to make sure that you follow good practice, you follow code standards, so that it will facilitate the maintenance of the software. Always think when you write code that the biggest cost is about maintaining the code. It's not about writing the code. Writing the code is done in few minutes. Maintaining the code, it's forever until the software dies. So it's really important to have a code that is maintainable. The pros and cons of the code review, the thing is you avoid to have bad code in prod. That's, the basic. And you help also the engineer. How? You help other engineer because other engineers are going to read the code and you're going to help them understand how the code works. There is an educational aspect of code review. When you send a code review to a colleague, the colleague will read the code review and start to understand how the code works. When you start a new company, the first thing you're going to do is look at other code review to start to understand the process, the coding standards, the best practices in the company. The cons of a code review as it is done today is it's really time consuming. In the company I worked at, we estimated that about 10 to 20% of your time as an engineer is spent on code review. And when your salary is about, in the US, $108,000 a year, it means that your employer is going to spend between 10K and 20K per year for you to do code review. It also slows down the development process because you wait for the code review to be accepted to finally deploy the code in production. And let's face it, it's an also error-prone process. Why? Because generally code review are done manually. So you send a code review and a pull request, and a colleague is going to look at it. But there is a bias here, and this is a human process. And as human, we fail by definition. We do stupid stuff all the time. We crash our car. We sometimes overeat the ingredient when cooking. We are making mistakes. Not all the time. It happens once or twice, maybe, occasionally. But we're still going to make mistakes. And these mistakes sometimes can cost us a lot. So the thing is, it's also an error-prone process, and we want to avoid that. So when we automate the code review, the way it works, and at least for Codiga, it works like this. But any automated code review process works like this. The developer initiates the pull request. It goes on GitHub. I took GitHub because it's the most popular coding platform today. GitHub sends a request to a tool to analyze the code. The automated code review platform send feedback to GitHub, and it annotates automatically the code on GitHub. So when you're going to look at the pull request on GitHub, you're going to see the annotation in the pull request on GitHub. And the developer can get feedback. So you have a feedback loop. The developer sends the code, GitHub asks for an automated code review, you have the feedback on GitHub, and the developer can fix the bugs and send an update to the pull request. That's the benefits of the code review. You have quick feedback on the code within seconds. At least for Codiga, when you send the pull requests, in 30 seconds, you're going to get feedback. And it removes the bias aspect of the code review. So you're going to make sure that your code review follow the set of rules of the automated code review process. You're going to check that your code is following good practice. It's going to check that your code is not using any deprecated code. It's going to check that you don't have any security issues. All this small stuff that is sometimes painful to check. And a bot will not miss these things. The bot will not miss these errors. But, after that, you have also some aspects that are, there are some drawbacks of the automated code review. One of the drawbacks is you don't know the requirement of the software. And you cannot check that the code you send in a PR is going to, in fact, implement the requirement of the software. So the automated code review process is really something to help you check the good practice, security, and safety aspect of the code. it checks the syntactic error and some semantic aspect of the code. But it does not check that what you implement is actually what you really want to do in terms of functionality. Let's talk a little bit about how to automate the code review. When you're on GitHub made the ecosystem really nice to add something we called applications. So we have a Codiga app you can download. So you go on github.com/app/Codiga and you can download the app and install it to your repository. So you install the app. After that, you create a project. And it's all done. You just need to initiate a pull request and check the result. So the integration is really seamless. You don't need to write any config file. You don't need to do anything. The only thing you need to do is install an app, create a project to make sure that your project is going to be checked by Codiga or whatever automated code review platform you use, and initiate a pull request. And then when you initiate the pull request, every time you're going to send a push to your pull request and an update of the code, the automated code review platform is going to check it and annotate it with any issue. So this is how it works in a nutshell. You go on the app, you click on install to install the app, and then once you install the app, you select the repositories you want to use to check your code. So sometimes you don't want to share all your repositories with a third-party vendor or a third-party app. What you want to do is just to use some repositories. So your team repositories or things like that. You click on install and authorize, and in that case, GitHub is just going to share the specific repositories with a third party. It's really important because for privacy and security reasons, most of the time you don't want to share all your repo with other people. And then you go on our platform or any other code review platform you have. You create a project for a personal account or for a group, and then you're gonna start your pull request. So let's look at this code. Actually, it's a Python code because I think Python is today the most popular language according to the TOB index. So I made this example with Python. So you have some Python code here that use, in fact, the typing annotations. So we have a class person. So that's probably what you learned in CS 101 or your first year in a bachelor degree. You're gonna have a class person, and you're gonna have two attributes. So the first name and the last name and the age. And what we're gonna define is a function to compute the average age of a person. And the average age takes a list of person. It's an optional because it can be none, and it takes a list of person. And I'm gonna compute the average age of the person. It's gonna return an integer. That's it's sure the average age of all the person in the list. And so this is what we're going to do. We're going to see if there is an array. What we're going to try is to map all the age in a list. So we're going to return, we're going to take the list of person. We're going to just take the age of the person from the list. You can see that here. And I'm going to return the sum of all age. So if I have a list of, 10 and 20, I'm going to have this sum here. That's going to be 30. And I'm going to divide that by the length of the array. So here, if I have 20 and 10 and I have 2, it means that it's going to do 30. I'm going to divide by 2. It's going to be 15. And I catch an exception here. And I catch an exception because here maybe the array is defined, but the size is 0. And if the size is 0, it means that I'm going to have an exception that is a divide by 0. And then I need to handle that exception, and I'm going to return none to say there is no average age there is no average age because the list is 0. I could return 0, but none is better because you don't have any person, so it does not exist. Then I return in the try, I return here. If I have an exception, I return none. And if there is nothing in the array as well, if the array is not even defined, so is none, I'm going to return none. And here I put computing all age done. So I test this code with making a first person that's called John Doe and is 51, and another one that is Luke Skywalker is 21. Luke is pretty young actually. And then I'm gonna print the average age of the person. So here I'm gonna invoke the function. In that code, you can see that we have at least 2 errors. So what is good about that code is we have docstring for the function. So that part is pretty nice, pretty good. I use a typing annotation of Python 3, which is pretty good as well. But the problem here is we have 2 major problems. The one is at line 25. And at line 25, what I do is I catch a very general exception. And generally, you don't want to do that. What you want to do is catch the specific exception you expect. And don't always catch exception, the generic exception name. So that's one issue. The second issue we have is at line 29, I continue to have statement in the function. But the problem here is I already returned. So it's something that we call dead code. It's a code that is never being executed. So at line 29, basically, this statement is useless. So this is the example I have as a code. What I'm gonna do is I'm gonna send that on GitHub and create a pull request. You can do that, of course, from the command line. You can initiate your pull request from the command line. It doesn't matter. I just do that because it's nice. You have syntax highlighting, and at least it's on GitHub. So we create the new pull request. We commit the file. I have this branch that is called Codiga demo. And then I create the pull request. So I put the comment, adding new code to compute the average age. And then I can see that when I start the pull request, I have this automated process, the Codiga code review here that say after 26 seconds, so when I say the code review is done in seconds, it's not, commercial talk. It's really what's happening. After 26 seconds, there are some issues in the pull request. And so the nice thing about this process is you specifically know in your code on GitHub where is the issue. Specifically here, when I have this average age function, the automated code review process is going to tell you here you are catching a true general exception. So this exception here is too generic, and what you should really be doing is checking an exception that is more generic. In the present case, what we really try to check is we don't divide by 0. So there's an exception for that in Python, and you should use that exception and not use a generic exception keyword. The second thing is the issue I was talking about, unreachable code. Here, I have this print statement that is being done after returning a value, and in fact, it just means it's dead code, and you cannot reach that code. So in fact, it's pretty. It's not a good thing to have it because it's not being useful. So either you wanted to put that print statement before the return, or it's just something that is not useful for your code. And this is exactly where we see the limit of the automated code review. It shows you that there is an issue, but it not tell you exactly how to fix it. Some code review tools are going to tell you how to fix it, but again, generally speaking, the problem here is the tool can give you alternatives, but it's up to you to really find the correct fix. Because at the end of the day, maybe here print was a debugging statement and you don't want to have it. Maybe in fact you want to put it before the return. So it's really something that is up to you. So let's fix the code. what we do here is we edit the code and we decide that first of all the statement on line 29 was a debugging statement, and we don't need to and we don't want to have it. So that's fine. We can just remove it. And the second fix is except on line 25, except of using exception, the generic exception, what we're going to use is zero division error. So we're going to catch that there is no divide by zero. In that case, you're going to see that we're going to show that there is there is an error if it was a division by zero, and then we're going to return none. You can see that again, there is multiple ways to do that. Maybe we should have checked that the length of the array was not zero. You have different way to implement the code. It's just the way we implement it here. We wanted to catch the exception. And then once I submit this new fix, you can see here that I update the demo. The automated code review tells you it's successful, analysis has been done, and there is no issue. Again, if you look at the pro and cons of the automated code review, it tells you really quickly there is an issue in terms of syntax, in terms of semantics, if there is any safety issue, if you follow good practices. All that part is pretty good and really amazing. But it does not tell you that the code is actually doing exactly what you should be doing. For example, if your coworker asks you to write a function to find the max age and not the average, the code review process, the automated code review process is not going to check that for you. So you still need to have a manual, somebody to check that the code is really doing what you are supposed to do. But the automated code review is going to really give you quick feedback within seconds about potential major issue in your code base. And this is what matters, because once you have this automated code review process that pass, you can have somebody to check that the functionality is correct and go faster in the way you develop code and deploy code. So this is something that really matters to go faster. It does not mean that you don't need a manual code review, but it's going to speed up the process because it gives you more confidence when you merge the code. So when a developer spends 10 to 20% of their time on a code review, with an automated process, you're spending more between 5% and maybe 10% at most. So you're still going to have a time saving that is significant and an increase of development velocity. Let's talk right now about how to monitor your code quality. So I talk about the code review and how you can check the code quality during the pull request. Let's talk now again on GitHub, but you can do the same thing with GitLab, Bitbucket, or your own coding platform, and check how you can monitor your code quality. So first, why do we want to check the code quality? And the reason is, as I said before, when you write code, it's read intensive. Developing code is a read intensive activity. You read code way more than you write code. So your code needs to be easy to maintain. Super important. What does that mean to be easy to maintain? It means that you need to follow code convention, have documentation, but it also means write small unit of code. Have unit of code that are easy to test. Have unit of code that are not complex. Make sure that bugs are being detected and removed. For example, if you are using an outdated dependency, you want to make sure that it's being flagged and all deprecated functions are not going to be used anymore. There is something else, and we are really good at doing that as developers, is duplicating code. All the copy pasta thing we are doing. We find a function here that do 90% of what we want to do, but not 100%. So we're going to copy paste this function and then do a new function. So instead of foobar1, we're going to do foobar2 that's going to implement new requirement or whatever, but we're going to duplicate the code. And when there is a bug in the initial function, we need to fix the bug also in the copy paste, like the other function, which is pretty bad. And you want to check if you duplicate code or not. That's something that is really important because you don't want to copy paste code over and over and over again. You want to instead have a small set of reusable code you can rely on. And if this code is small, reusable, and tested, when you reuse it, you are making sure that the code is tested and do exactly what you want to do. So you're going to avoid bugs. So checking the code quality is super important. Many developers will not follow this good practice to check the code quality. But that's something that is really important on the long run. When you write code, many times you write code and 2 months after you read the code, and the only thing you think is, what the hell I was thinking? because basically you cannot understand the code you wrote yourself. One example of issue is the code we just saw today, catching a very general exception. That is something that is pretty bad. Dead code is also something you don't want to have. One thing that is good in that code is starting to have documentation. So even here, the documentation is quite small. You need to have that to at least know what are the different failure mode, failure condition, what is being returned by the function. So how do you measure code quality? You have multiple angles, and that has been a big debate. I believe that one of the ways you measure code quality is by checking the number of violations and bugs you have. But also, you need to distinguish between a severe bug, a bug that's going to cause you a potential security issue and a breach of privacy. So you need to check that, the number of bugs with the severity you have. So you don't want to have a lot of high severity bugs. The second thing you want to check is the intelligibility of the code. So how easy you can understand the code. And for that, there are two metrics that are important. The first is function length, and the second is function complexity. The function length means you make sure that you don't write long function. You write small unit of code. And you're gonna probably ask me, what is the right size? What is the right size and how big a function should be? The rule of thumb, so there is no magic answer, but the rule of thumb is if the function does not fit on your computer screen, it's probably too long. And the reason is because you want to be able to see the big picture. You want to be able to see the function while you develop and write code. The other stuff is, the other metric is called the function complexity. And what you want to do here is checking that you don't, your code is not too complex. And by that, we mean that you don't have so many if, else, then, for loops. You don't have you don't want to have 3 for loops that are nested. So you want to have code that is easy to see and easy to understand. And the last part is measure the number of code duplicates you have. How much of your code is copy-pasted? How much of your code has been just things that have been taken from other files? So you want to measure that. It's really important because you want to make sure that when you do something once in your code base, you do it well with one function in one part of the code base, and you don't duplicate that. On our platform, so you have other code quality platform. On Codiga, at least, you have something that is called the quality score. And the quality score is an aggregate of all the different metrics: number of violation and bugs, number of long function, number of complex function, and we're going to also show you the amount of duplicated code. So when you go on the dashboard, you can see how many languages you have. You can see what are the category of the violation, if it's code style, best practice, security, and so on. You can see the violation. So for example, for this project, the highest violation is 4. So it means that it's not a big issue. Violation 1 is the most important. Let me take more coffee. And then it also shows you the number of long function you have and complex function. So it's really tell you how much percentage of your function are long or complex and how much of the code is duplicated actually. So it gives you a number. So 93 is a number that takes all the violation, and it also computes this score based on the number of violation, long function, complex function, and duplicate. And it computes that number based also on the number of line of code. Because of course, having 10 long function is different. Having 10 long function with 100 function is different than having 10 long function with 1,000 function. So you need to look also at the size of the code base. And so to make sure that your to measure your code quality at every change on GitHub, what you can do is just having a GitHub action. So you're going to have a CI/CD pipeline, and in your CI/CD pipeline, what you're going to do is each time you push new code on GitHub, GitHub is going to ask a third-party service, in that case Codiga, to check at the code quality and give an analysis report. And you can have that graphically on the code quality platform you choose, but what you really want to do is always improve the code quality. So you want to run analysis at each code change, push a pull request, and you want to check your code quality against the baseline. So when you start a project, for example, if your code quality is, let's say, 50, what you want to do is making sure that your code quality never go below 50 and always go above. So you're going to always improve your code quality. It means that if you make a code change and you introduce new long function, new code duplicates, it's going to be rejected. So based on the code change, you do this code quality check will either accept or reject the code. So when you have a pull request, for example, you can check the code quality metrics and then reject the code change if the code quality metrics are not met. This is how it works. For when you have your CI/CD pipeline on GitHub with a GitHub action, because the GitHub action lets you define very easy rules that are really easy to understand and define what's going to happen is the developer going to push new code on GitHub. GitHub is going to request to analyze the code and then going to report the code quality to GitHub. And GitHub is going to, based on what you define in your CI/CD pipeline, accept or reject the commit. So we're going to show you if the CI/CD pipeline passed or not for the code quality. So the way we implement that is with a GitHub action. A GitHub action is a very powerful CI/CD pipeline that is easy to use in GitHub. You can do the same thing with other CI/CD pipeline provider, for example, with Circle CI or AWS Code Build. That's definitely not an issue, but we're going to use GitHub action here because it's something that is very popular. It's used by thousands of developers on the planet. So we're going to use this GitHub action. We made it easy with Codiga to have a GitHub action available, but again, you can have that GitHub action with any code quality platform. That's not specific to Codiga. And you can have a pass or fail based on the code quality. So when you do the code quality on GitHub action and you check the code quality on with the GitHub action, what you're going to do is define a file that is called .github/workflow/main.yaml. So it's a YAML file. It follows the YAML syntax. And the way it works is the following. You're going to follow the GitHub syntax for the CI/CD pipeline for their action. So here what we say is on push, we're going to have a job that is called check quality. It's going to run on Ubuntu latest. The name of the job in the CI/CD pipeline is going to be called Codiga check. The steps are, there is one step. We check that the code meets the quality standards. We're gonna use the Codiga GitHub action. So the GitHub action I was talking about that we developed. And here you're gonna put the parameters. So you can omit all the parameters. You can just use one of these parameters. That's not a problem. what you do here is you're going to have your token repo. So the token repo is what is used to check out the code. So you specify this. Here you put a token to use Codiga. So you get that token on app.codiga.io, and it's used to use the Codiga service. So you need to define this token on app.codiga.io, and then it's going to use your account to make an analysis. You have a minimum quality grade, which means a quality grade is based on your quality score. So you have different range. If it's excellent, good, warning. So here what we want to do is making sure that you never go below warning. If you don't want to use a quality grade, you can use the quality score. The number I was talking that is aggregate of violation, bugs, long function, complex function, and code duplicates. Again, I never want to go below 50. So here it's if the quality score go below 50, it should not pass. This commit should not pass. If you don't want to use the quality score or the quality grade, what you can do is define the max defect rate. Max defect rate means I don't want to have more than X violation per 100 line of code. So in the present case, we do 0.002, which means I don't want to have more than 2 violations per 10 line of code because the rate is per 100 line of code. Similarly, here for the max complex function rate or long function rate, it means I don't want to have more than 1 complex function per 100 function. So it really tells you you can really define metrics and quality metrics for each of the dimension, either complex function, long function, number of bugs and violation you have. Finally, here you can specify the product name. The reason why you can specify the product name on Codiga is because on Codiga you may have some specific settings and preferences, and if you put the name of the product, we're going to reuse these settings and preferences to do the analysis. So if you ignore some violation, if you set a specific threshold for complex function or long function, we're going to reuse that. If you don't specify your project name, it's going to just use all the generic analysis settings. And you can see that if I do a commit on my GitHub action, my CI/CD pipeline is going to run and check that my new code meets the quality standards. In the present case, for example, here, it tells me that, okay, the analysis score, so the quality score is 9 and it's below 50. And because of that, it means that the CI/CD pipeline didn't pass. So the Codiga check is not being checked. I mean, the Codiga check is not being checked. And then your commit is going to be rejected. You can still approve it on GitHub, but you can also configure GitHub so that if no check pass, you cannot even merge the code. But at least it tells you, it shows you the code quality metrics and where do you stand regarding to your quality standards. So that's what I wanted to cover today. If you want to learn more, you have, again, this presentation is really about code quality and why you should care about your code quality. And this is something that is really close, to my experience, because I experienced that where I was working at many companies. You have other code quality platform. If you want to use Codiga, you can learn more at codiga.io. We have extensive documentation to use the product with different CI/CD pipeline with AWS, Circle CI, GitHub, GitLab, or Bitbucket. We have a lot of tools to integrate with GitHub, with the GitHub app or the GitHub action. So feel free to go and use them. It's free. You can use them for your personal projects or your team projects. And don't hesitate to contact me if you have any question.
Hey, Julien, thanks for the presentation. Very cool insights, very cool tool.
Thanks.
We do have 2 or 3 questions, so I would jump right into that. There's a very generic one, but maybe you can say a couple of personal thoughts. Koala is asking, how do you decide what is better code?
Yeah, so we have multiple metrics. So one is the number of violation bugs, the number of long function, complex function, and duplicates. That are the 4 metrics we are using: bugs or violation, long function, complex function, and duplicates. For the bugs, generally what we do is we use tools that are open source and that are based on general feedback from developer or even the coding standards. Like in Python, you have a PEP, that is a standard to define how the Python code should be written. So we use this. We use these different best practice and rules, either from the developer community or from the coding standard, from the language standard itself. But the thing is, you may want to sometimes to ignore a violation or a bug or a rule that we have to check the code, and you can do that. So you can change and you can specify what rules apply to your product. Same thing for the long function and complex function. For me, a long function is a function that is more than 50 lines of code, between 40 and 50. After that, it starts to be really long to read. But some people are comfortable with 100. So what we did with the platform we implemented is to be able to define the threshold, and you can tweak it. When you create a product on Codiga, you can say, for me, a long function is 100 lines. Same for the complexity, you can change that. And for a code duplicate, there is something that is how big should be the code duplicate to be considered a duplicate as well. Because if it's only 1 line, you're going to have code duplicate all over the place. So the answer is really about, we take the good practice from the community. You can still ignore rules that you don't like. And for all the other metrics, you can define your own threshold. So it's you can really customize the platform to your needs.
Okay. Then we have one question from Vuga, who's asking, does the ACR tool support integration with other version control systems, for example, Bitbucket?
Yes. So our platform, at least our platform, I can talk with about the other code quality platform, but we integrate with GitHub, GitLab, and Bitbucket. We have a system that works with all these cloud platforms, and we provide the same functionality for all the platforms. And it's free. It's free for the 3 platforms. So it works well. The only thing we don't support today is Mercurial, for example, but it's not the market share for Mercurial is low, so we don't support it.
Okay, good to know. Then 2 similar questions also from Vuga and from Anthony, who are asking about some maybe differences or comparisons with other static tools like SonarQube or SonarLint.
Yeah, so it's basically quite similar. The thing is, on our side, what we did is implement our tool with with a lot of open source tools. So our tools are really powered generally by the community. If you look, for example, for Python, we use PyLint and Bandit. And these 2 tools are developed by the open source community, and they are really based on the good practice from the community. SonarSource and SonarLint, they have their own rules that are running, and sometimes it matches what the open source community wants, and sometimes it doesn't. On our side, we made the bet on using what the open source community is doing. And we believe that, generally speaking, in terms of quality, in terms of tool quality, the open source community is pretty strong. So that's why we decided to go with them.
Okay, thank you. And then last but not least, a question from my side. What do you think, how does the future look like for tools like Codiga and for this whole code quality tools, especially with things like OpenAI coming up, and will it change somehow, or what do you think? What's your vision?
Yeah. So something that is really interesting is what's happening with OpenAI and CodeX and GitHub Copilot. I think many people last year have been really amazed by the tool. But the thing is, keep in mind that GitHub Copilot, when you look at the quality of the code it generates, there is a study, I think 6 months ago, that was published and shows that 40% of the code of GitHub Copilot is insecure and have vulnerabilities. So that's the first thing. The second thing is you can have a privacy issue as well. We keep hearing about the licensing issue of the code you import. That may be a problem.
Yeah, that's still very beginning.
Yeah, exactly. That was really at the beginning. And some people say there is a problem. Some people say there is not a problem. It's really hard to know. And until we really have clarification about with lawyers, we will not know. This is what I think. I think GitHub Copilot, ultimately, we're going to go there. We're going to go to a place when you can have better code suggestion. You start seeing that with Type 9. You start seeing that with Copilot. But it's going to be freaking hard to have it right. Think about self-driving. People try to promise a self-driving car for right now 10 years, and it's not there. It's not even going to work in 5 years. It's going to take a really long time. For coding, it's the same. Copilot can help you write some code, but it's really hard to find the exact correct code that you want to write. So you're still going to have that. And until you can really automate the coding process, you're still going to need to write readable code, maintainable code, making sure that you have no bugs. GitHub Copilot may use a piece of code that has been used, that has been defined 3 years or 4 years ago and have vulnerabilities and security issues. So I think these tools are going to help, but we are really just at the beginning. On our side, what we are betting on with Codiga is not having a coding assistant that is AI-based, but having a coding assistant that is collaborative, so that you can share snippets of code you can reuse. I truly believe that developers are really powerful, person, and they can share piece of code, and other developer can reuse them. I think there is something here that is not being used enough. And then you can check later on your pull request if this piece of code are correctly reused. So for example, if you work in a company, you will share a snippet of code with your team. And then if a teammate try to do something like you did and miss an argument or miss a line or miss something, we're going to be able to flag that in the code review. So I believe in short, I believe in the AI approach. I believe it's way too early. I think there are many steps before it's going to work. And this is what we are betting on.
Okay, thank you very much for these insights. I can only say it was really a pleasure having you as a speaker, especially knowing that you woke up so early to join the conference. So thank you so much, Julien. I wish you good luck with Codiga, and I hope to see you soon again at another event of ours.
All right, sounds great. Thank you. Thanks for having me. Bye.
Thank you. Bye. Okay, and again, we are going for the last short break of today. So just around 13-14 minutes, and then we are back with the last session. So stay tuned, get maybe a cup of coffee or tea, and see you in a couple of minutes again.
found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello and welcome back to our very last session of the DevOps Day. Last but not least, we have two amazing speakers from PlanetScale, Johannes and Lily. Johannes works formerly at GitHub. He's an open source enthusiast. He loves developer-friendly databases. He's a true expert on CI/CD. And Lily is the area manager at PlanetScale. She was as well at GitHub formerly, and managing and consulting customers through the transformation process. And so give a warm welcome to Johannes and Lily.
Hi-ho.
Hi, how are you doing?
You guys okay?
Can you hear me?
I can hear you well. Can you hear me?
Oh, okay, perfect. So before we start, would you like to give us a sneak preview of what we are going to learn from you?
Sure. Today you will learn how you can use a database workflow together with your code workflow, two worlds which are typically completely apart from each other, finally merge together.
Okay, sounds interesting. I would say, the stage is yours. Have fun, and we will see each other in the Q&A session.
Thank you.
Thank you. Cool. I guess our screen is visible, right? Just double checking last time. Seems so. So welcome everybody. As said, we like to talk about how to branch your database like your code. So basically how your schema changes and your GitHub pull requests or GitLab merge requests can go hand in hand. And whenever Lily and I are designing talks, we try to think about our audience, which is you first, put ourselves into your shoes. And from your shoes, the question is, why should I spend the next 40 minutes with you? What's in for me? So for you, I hope we have at least 4 things in stock. First of all, we like to talk a little bit about why database schema changes are so hard and why they are so different from the ordinary code workflow until now, at least. But the main part of our talk is not slides. We really like to have as much live demos as possible. And those live demos, they will be done in a way that you could either just follow us and enjoy, or you can even better join us and basically do the same steps we do as well. Don't be afraid, there's not a lot to type. Instead, you basically just click on a couple of links. And for that, you just need a GitHub account and a free PlanetScale account. If you haven't created a PlanetScale account yet, you would just go to planetscale.com and go on sign up or sign in. And you can use, for instance, your GitHub account to get you started. So it's really just a couple of seconds. The great thing, if you followed our demo like this and do not only watch, is that afterwards you would also have a database for free, which has these branching and merging workflows already built in. And you could use this database for all your projects for free forever.
Yeah. Thanks, Johannes. And the PlanetScale database is actually based on the open source framework that is used by companies like GitHub, Slack, and Shopify called Vitess to scale their MySQL setup. So we're going to give you a bit more background information on that. And there is going to be 2 chances to win some swag. So one, if you have a little bit of prior knowledge and can answer one question that we're going to have relatively in the beginning. And 2 is going to be in about 5 minutes when we're starting the demo time. As Johannes said, make sure you have your PlanetScale account ready for that one. So let's dive into it. Before we get to that, you had a quick intro from our side. Lily Salter Basic is my name. I'm very happy to host you today. Used to be at GitHub and worked with our customers on their DevOps transformation in Germany, and now very happy to support our customers in Europe at PlanetScale. And I brought with me Johannes today.
Hi. I guess in the beginning, it was already mentioned that I also joined from GitHub. And it's funny because there we were working a lot with branching and merging based workflows. Before GitHub, I was the director of engineering for a company called CollabNet, which invented Subversion. And we come back to the painful memories of Subversion later in this talk as well. So without any further ado, what is PlanetScale about?
Yeah, so founded in 2018, 85 whole employees that come from companies like, as we mentioned, GitHub, DigitalOcean, Twitter, and so on, who managed super big database settings over there. And also our co-founders, Sugu and Shiten, who came from YouTube and started Vitess there. But the question is, why did they start Vitess there? Why did they do it, Johannes?
Well, in 2010, when Sugu and Jiten were working as site reliability engineers for YouTube, they had three problems or challenges. I mean, a good problem to have was that YouTube was super popular, and its views and videos were increasing every single day. So their user growth was just fantastic. And YouTube was just acquired by Google at this point. And now they needed to scale a lot. And the database they were using was MySQL, and they threw all kind of hardware at the problem, right? They maxed out the number of CPUs, the number of SSDs they could attach to the machines, but still it couldn't go with all the load that was caused by the YouTube audience. So they needed a way to horizontally scale, meaning not just one server, but many servers, and not just read replicas, but really the ability to split up the databases transparently, so that for the application logic, it still looks like one database, but in the background, this is all done via sharding. That was the first challenge. The second big challenge was that Google and the entire world in 2010 just learned about Edward Snowden's reports, where was said that the NSA and CIA basically had access to all kind of data centers, including the network. So Google obviously didn't want this to still continue. So they told YouTube, who just got acquired, you folks have to move from whatever data center you are currently using to the new data centers we are building right now, which should be safe. And the only way how you can run any service at Google is with their own services. And the service that should be used for YouTube at this point was Borg. And I guess many of you know that Borg was the predecessor of Kubernetes. So the MySQL folks, our founders from PlanetScale, had to scale both horizontally MySQL and at the same time also adopt the predecessor of Kubernetes. And what came out of this was the open source framework Vitess.
Yeah, Vitess from 2010, so 11 years old. Today it's a CNCF graduated project. And the architecture we have brought for you, and this is also where we actually have our first question to win swag, as we promised. So when you look at the Vitess architecture, you notice that there is many components that start with VT, like Vitess. But the VT actually goes back to the original code name of the project at YouTube. And those who followed the talk of our CTO at KubeCon, maybe, we've also linked it here and there in resources that we had online before, you might know the answer to the question, what was the original project name of Vitess at YouTube? And if you know the answer, make sure to put it in the chat. I'm having a look at this. We're giving you like 30 seconds to give an answer. If you don't know it, don't worry. As we mentioned, there's another possibility to win swag, and we're going to ask the question whenever we give our next talk at a conference as well.
Yeah, we won't stop asking that questions until everybody knows. And while you still have, 20 seconds left, as you can see, this is the architecture of Vitess, where horizontally sharding is built in. So from the MySQL client, it looks like a single MySQL database, but a component called VT-gates makes sure that depending on your query, it goes to the right shard, so that the data in each of those tablets stays at a manageable size. Vitess can do many more interesting things, including non-blocking schema changes, which we'll see in a moment. So that was the 30 seconds are over. Anybody who answered that question so far?
No. So
Nope.
let's get the secret out. The answer to the question is Voltron, and the reason for that is because YouTube actually had to puzzle a lot of different pieces together in order to revamp the architecture to deal with the high MySQL workload. So like basically change the whole scaling system, bringing together MySQL and, as Johannes mentioned, also Borg, and that's why they came up with the name Voltron. Yeah. So today, 11 years later, there's all these companies that previously had scaling issues with MySQL, dealing with petabytes of data like Stripe, Square, Vinted as well. And then, of course, there's the company that we came from, GitHub, where we're also very well acquainted with the GitHub workflow that has been established. And quick reminder for some of you, because I think most of you will know the GitHub workflow actually, but the way it works is whenever you need to make code changes to your existing application, you can create a feature branch to have your isolated environment to be able to try out whatever you need to try out, right? So you open your feature branch, then you add your commits to the code. And in order to figure out whether there's any merge conflicts and also to get feedback, you open the pull request, right? The big trademark thing that GitHub came up with in order to make developers' lives so much easier. And fun side fact is actually that this is the laptop that the pull request was invented on. So it's in the GitHub museum that they have in San Francisco, a little small one in the office. But in all seriousness, back to the workflow, this is also where you are able to discuss your code changes with your fellow developers or colleagues or whomever you're working with, and then to also ship it, right? And ship it and make sure that it works. And only afterwards, you actually merge it. And this all looks super easy, right? With Git, it is easy to merge code branches, but going back when Johannes' software career started, this was differently. And he remembers that it was very different from his time at CollabNet, which is the company that founded Subversion.
Yeah, you're bringing up a, well, kind of painful memory. I think it was in 2008 when Dennis Torvalds did that very great talk about Git at Google first time. And he was basically saying then that branching is not the issue, merging is, right? And that the developers from the Subversion community, that they were looking wrong at the problem, right? We always focused more on the branching as we did on the merging aspect of it. And it was painful, but he actually had a point, right? I mean, we learned that later at GitHub, that nowadays merging seems to be a really easy operation. And nobody is thinking back too often 15 years where merging was still a pain in the developer days, right? Where people had to spend the entire weekend just figuring out how to reintegrate branches, for instance. The same problem of merging changes is still the case in the database world, right? In the database world, in most cases, one does not simply merge database changes to production like we are used to in any kind of Git solution like GitLab or GitHub. And the main reasons for that is that in databases, if you wanted to change the schema, so your tables, your column structure, you always do this in an imperative delta-based fashion. What does that mean? You have your current status, and then you say, for instance, remove a column or add a column. So it very much depends on where you were starting from. It's not like Terraform or any other infrastructure as code declarative thing where you say, listen, this is how my table should look like. Now figure out how to get to that state. But you really have to be careful where to start and tell precisely how you get to the next state. And if your development environment is just a little bit different from your actual production environment, it could be that some schema change which worked perfectly well in a dev does not work at all in production. Could just be that somebody else, a different team, has changed the schema since the last time you tested. right? And you hadn't have any possibility to see any conflicts before you actually did apply it to production. The other thing which makes database changes harder is that there's actually data involved, meaning the data has to stay, right? It's not just that you wipe out the code with a new commit, like in Git, but you always have to keep your data. And imagine, for instance, that you tested a new index, which is unique on a certain column. And in your test database, every single value in that column was different, so it was unique. Whereas in production, you still had those very old customers where this column did not even exist, and you have null values into it. And now this index operation does not really work in production. You have different data over there. That's the typical problems every single team is running in. And if you have the size of YouTube or GitHub or Spotify, then you get all kind of different problems as well. Because if you change a database table, like adding a column to it, you have to copy the new column to all the existing rows. So if you have gigabytes or even petabytes or terabytes of data in your database, it can take hours or even weeks before those changes will actually be applied to the production database. The problem gets even worse because during all of this operation, you won't be able to do any write queries to the database. There will be a metadata log on MySQL, and if you try to do a write query in between, it will have to wait until that query change is done. And that is something people typically only learn in production when it's already too late, right? And it's probably one of those nightmare situations every DBA in a bigger company already experienced. And once you experience that nightmare situation, you typically introduce a process. And this process basically means first, nobody from the development team can directly do any schema changes to your production database, but they have to suggest those changes after they have tested it. And then there will be a review committee of database engineers who carefully review the impact of those changes. Will it touch tables with a lot of data in it so that you can only run it on the weekend? Are there different teams who have different changes they want to do, and can those be applied together, or are there any conflicts? So those folks will make sure that everything works. And this reminds us a lot of how Subversion or CVS worked when you were doing reintegration of branches, where you blocked weekends to decide how to actually get all of those changes in. And the question is, how can you get to a point where this workflow is basically as easy as it was in the code space, right? From Subversion to Git, how does it look in the database world? So you would be surprised if there was no way how to do it, right? It's all doable with open source tools that support non-blocking schema changes. One of those tools, called Ghost, or also GitHub Online Schema tool, because it was initially developed at GitHub, has this concept of so-called ghost or shadow tables. So when you do any kind of change in the database, it will not do this change on the tables directly, but it will first create a ghost shadow table where it applies the changes and see whether this works. And it copies all the data from the original table over there. And then the really cool stuff is that it can keep up with the changes in the original table. So it transparently copies any ongoing inserts, writes, or deletes into the shadow or ghost table as well. And once this part is complete, you can then revert the ghost table or swap the ghost table with the original table. So do a cut over, which is atomic, and during all this time, write queries can still happen. So you don't block your database, and you also learn if anything is going wrong. It still takes time, but you don't have to tell any feature team that they have to wait forever until you can, for instance, apply one of those changes. Ghost is integrated with Vitesse. It's all open source. You can use it with any MySQL database. What PlanetScale did, as many of the folks, including the Ghost founders, joined PlanetScale, was to put a GitHub or Git-like workflow on top of it. We thought, wouldn't it be cool if you could branch a database as well? Branch in a database would mean you have the very same schema as production, so that you can be 100% sure you're not starting with the wrong schema, but really exactly what is in production. Then you can apply your schema changes. Those branches are by default empty or have only a little bit of data, but the same schema. So schema changes apply there very, very quickly. You can connect your application to it, your testbed. It's a full database, right? It's just isolated from production, like in a pull request. And then you can suggest all the database schema changes similar to a pull request and a deploy request. And as part of this deploy request, other folks can chime in and see whether there's any conflicts. You will also see that in the UI, and then have the ability to merge this all in with the GitHub Online Schema Change tool, which is integrated with Vitess. That's where our slides end, because I said the majority of this talk should be live demos. So this is a planet scale. There's organizations similar to GitHub. If I'm going into any organization, you can see the databases which are in there. If I go to any database, you can see that there's currently some SQL operations going on, and how long they take and what tables they affect. That is kind of in a straightforward database, right? You can also go to a console and, for instance, find out how many rows are there, or list those rows if you wanted to. So that's just standard functionality. But what is different is that you actually do have branches, right? So this is the production branch, but then you can also have other branches, developer branches, where you can connect to and test stuff in isolation. But you can also use those branches to do schema changes and then suggest them as deploy requests. Like here we have a deploy request, which is actually suggesting to add a column called counter to the database, and I could approve this or comment on it. And if I wanted to, I could just press this button, which is basically a merge, and then this change is asynchronously transported to the production database. So I don't need to give my developers access to the production database, just to those feature branches, and then merge stuff in. So far, this looks quite a bit like the GitHub workflow or the GitLab workflow. But what would be cool is if all of this functionality could be directly integrated with GitHub. And this is what I will show you now together with Lily. So everything out of this functionality in the database itself can be scripted. We do have a command line interface called pscale, planet scale command line interface. And with that, it's possible to do everything programmatically, like listing all the databases, listing the regions where a certain database branch can live in, find out about all open deploy requests, and so on. So the idea would be to use this functionality of the command line interface and integrate that into GitHub with GitHub Actions, so that it's really a first-class citizen. In that case, I created a repository which is called Jonico pscale workflow helper scripts. It's also featured or starred in the main page of it's a pinned repository I have. And maybe somebody can also put that link into the chat, because this is the repository we would like to work together now for the live demo. Right? It has all kind of GitHub action workflows included as part of the .github repository folder. I've seen that in the previous talk, there was already the mentioning of GitHub workflows, which means that all of those workflows will be part of the repository if you just created a copy of it. And I will go ahead and create a copy by just clicking on that green button. So anybody who likes to follow the live demo with your own account in PlanetScale, just click on use this template for Jonico pscale workflow helper scripts. And then you can create your own organization. In my case, I'm using a PlanetScale demos, and create a repository called WeAreDevelopers, for instance. But you could call it however you want to. Can be public, can be private, does not matter. What matters is that all of those GitHub actions are automatically included, which means that if we are opening any pull requests now in this repository, the GitHub Actions will listen for certain comments, like if I do /ps_attach and mention a deploy request in PlanetScale, it will automatically get associated. Or if I do something like ps_create, it will create a database feature branch out of my pull request. And you will see some of those commands in a second. What we also have in this repository is ability to automatically create you a bootstrap database so that you don't have to set up anything manually. All you have to do, basically go to your repository, to the Actions tab, and follow those steps. There's a first workflow in it, which is called create database. And if I run this work, go ahead.
Can you zoom in a little bit?
I can, absolutely. Just a second. That's probably the most I can do.
Yeah.
Cool. Yeah, if I go to the Actions tab and then on the first workflow, create database, I can click on run workflow. And then this is a manual GitHub workflow. It will kick off in a second. You will see an entry over here. If you click on whatever is showing up, in your case, there will be a job created, and this job has a click here in its name because we need to find out the credentials from PlanetScale so that we can actually go ahead and create a database. And for this, the GitHub action workflow will show a link. If you click on that link, you will have the ability to confirm that it's you with your PlanetScale account. And after that, it will automatically find out your organization and the name of your GitHub account and create a database in your PlanetScale account. So in my case, it will be a database called example DB Jonico. And as you can see, it's not immediate, but it should be finished in less than a minute. What is going on in the background is that an entire Vitesse cluster is now provisioned, and inside that Vitesse cluster, you will have all the Vitesse components you have seen, like the VT gate that are responsible for transparent sharding, multiple replicas in different availability zones, failover orchestration logic. All of this will be now provisioned in the Kubernetes cluster, and once this is done, which is the case right now, we can actually go to the database and check it out. I believe in this case, it should already almost be done. It's just promoting the main branch. So far, we will only have one branch, and that means if we go back to PlanetScale, and in this case, it's at the Jonico organization, there should be a new database, in this case, example DB Jonico, just created a couple of seconds ago. And so far, it just has one branch. What we like to do right now is to develop a new feature, right? And this new feature should use a GitHub pull request as well as a database schema change. So let's just do that by going back to our WeAreDevelopers repository. And as code changes are sometimes a bit complicated, in live demo, it's tough to agree on one particular programming language. We thought we do a code change, which is actually a markdown change. The markdown change we want to do is that we will point to the issue templates of this repository. So if you click on issues and then new issue, you'll see that there's already a GitHub issue template in it. And the GitHub issue template allows you to create new issues with a couple of forms. And in this case, we want you to win some swag. So if you do have any kind of example how you use our workflows, just fill out that issue template. The point is, the knowledge about this issue template so far is not on our main web page of the repository. You wouldn't know that this issue template exists. So let's add this issue template in here as a pull request. So I click on the edit button of our WeAreDevelopers README file and just add any kind of text, basically just showing that this is now a code change, right? In my case, I added a section that is pointing to this issue template so that if you fill it out, like somebody added a Prisma example, how to use our workflows with Prisma, then you can win some swag. So that should be our code change. And this code change, and I'm making screen, try to make the screen bigger again. Bear with me on that. It's just adjusting the size so that this code change should be as part of a pull request, and that pull request can be in a branch which we call WeAreDevelopers, and we are proposing that change now. And what we are doing in that change is to actually add the section with the community usage examples. So we are explaining what this change is about. We just point to existing community examples as GitHub issues, and we also reference that issue template. So far, so good. So far, it's just GitHub code, right? We haven't done anything interested in the database world, right? We just created a pull request, and there's just this change in the markdown pointing to the issue template. What we like to do right now is to actually create a feature branch in our database that corresponds to the code change we just did. In this case, we are using an issue comment inside GitHub called pscreate, and I will show how this is implemented in a second. And pscreate allows you to specify the schema change you want to do. Like in this case, we just want to add one database table to it. So I click on comment, and while this is commented now on GitHub, you might wonder, how does GitHub now know that it should do anything? And the answer to that is that GitHub Actions do not only listen to events when a commit was pushed or a pull request got created, but also if, for instance, somebody is adding a comment to an issue or a pull request. So you can create your own commands like pscreate or psapprove or psmerge, and then kick off workflows in the background. And this is all done with the workflow files in the .github workflows directory. In this case, the bot, the GitHub action bot, is asking me to authenticate again with the link, which brings me to the GitHub action workflow, which is currently running. Trying to make this a bit bigger as well. And if I confirm again, then it will actually go ahead and create a new database branch for me. This database branch will have the same schema as the main branch, and then we will add automatically the schema change we suggested in GitHub on top of it. Then we can test it in isolation and work with a database. And once it's all running fine, we can have it approved and also merged. That's the idea behind that. It again will take a couple of seconds before that branch is provisioned. The reason for that is it's again an entirely separated, isolated VTest cluster with all the functionality. So if you ever are in a situation that you needed a developer branch for databases, a isolated environment which has the same characteristics as productions, this is what branches are about. Then you would do the changes, and then you can have a deploy request, which is reviewable. Right now, you're seeing that the schema is changed in your request and a lot of debug output. But what we are really interested in is the pull request, because this one got updated now. You see there's now a database branch associated with it. There's a deploy request and a branch connection info. I will start showing the branch connection info first, because that is a one-time secret, meaning only the first person who accesses that will have access. This is for security reasons, so that if you have a public repository, not everybody can read how to actually connect to your database. But this is basically the way how you would connect to that specific feature branch, which is called WeAreDevelopers. And it has a slightly different schema, right? It now includes our swag winners database as well. And if we wanted to see how this was already proposed to be merged to production, to the main branch, there's also a deploy request associated with it already. And in that deploy request, basically you see the diff that now an entire new table should be added to it. And this could now be reviewed or approved. So I don't want to review or approve my own merge requests, or in this case, deploy requests. So Lily, could you go ahead and approve that one for me, please?
Of course.
So Lily could do that directly from the web UI of PlanetScale, or she could do that using the PlanetScale CLI, and she will use a third way of doing that by adding one of those magic words as part of the pull request. Namely, she's doing PS approve in here so that it's also documented that the database changes associated with your code changes work well. And similar to how the first command was processed, we also have that for the PS approve command. So there's this .github workflows directory, and here you can see all the actions. Like there's one called issueOps PlanetScale command, and it's reacting on issue comments. And if any of those comments is, for instance, PS merge or PS create, or what Lily used, PS approve, then it will kick off the pscale CLI and interacts with PlanetScale and comments back on the pull request. So if we go back to our pull request, then you see that authorization and work is still in progress. And once this is finished, you will see that it has been approved, meaning if we go to the deploy request, you can now see that Lily said it looks good to her. So she can now deploy that into production. So please go ahead, Lily, and do the merge for us.
Go.
In case, I do realize that this demo was kind of a lot to follow. The first steps was basically to create the database, and you don't need to type anything for that. But then for the rest, it was about creating a deploy request using a pull request. So it's quite a bit of things to do. If you want to completely finish that thing, you could either watch the recording of this, or you would just follow those steps in here, like step 2, step 3, step 4. These are all manual workflows where you can basically achieve the same thing by just running the steps. Like if I wanted to add a certain column in a different branch, I would just run this workflow. Or if I wanted to create yet another pull request, right, I could just say how the name of this of the feature branch in the database should be named, and then what kind of DDL I want to run. So you can do it either all from a GitHub pull request or just by just running those actions. But the idea is that you don't have to type that much. Going back to our PR, PS merge was run, and we have merged the schema changes successfully, meaning you can now see that the swag winners table is part of our database as well, also in the main branch. So if we look at the schema there, you see there's now a swag winners table as well. Okay. So that concludes the the live demo. As said, now that we merged all of this, there should also be an updated website saying that you can create your own examples based on that workflow. And if you fill out the issue templates, we will ship you some swag, so you will get some t-shirts. Very interested what else we get apart from Prisma integrations. And what also wanted to mention is that Vitess has many other amazing features. Like we today covered non-blocking schema updates, but there's a lot about high availability, properly scaling on Kubernetes, or dealing with thundering herd problems. This is all something you can find out on vitess.io, the official webpage of the Vitess open source project. And if you want to have this all already fully packaged up with branching and merging deploy request functionality built in, then it's PlanetScale's a free serverless database.
Thanks, Johannes. So we hope we actually could trigger some interest for you to try this out and have easy schema changes that you can make, like hopefully as easy, at least that's what PlanetScale is striving for, is to make schema changes as easy as GitHub made Git workflows. So yeah, if you have done so already while our talk, make sure to let us know so we can review it and get some t-shirts to you. And I saw that there were a couple of questions in the chat, so we'll get to that now. But first of all, thank you so much for listening and for spending the time with us. We're also very happy to hear your feedback, actually, because we hope to address more questions in the talk if you have them. So feel free to reach out to us as well on LinkedIn. Thanks. Okido.
So thank you so much, Lily. Thank you, Johannes. Very cool insights. Very interesting service. I would say we jump right into the questions, and also thank you, Lily, for taking care of the chat during the session.
Of course, yeah. I saw that there were a couple of questions on the way. So if you don't mind me, there was one where I think there was a little bit more context needed, because we had David asking whether the database is equal to all SQL databases like PostgreSQL, Oracle, and so on. And the question was whether it is an equal concept. So in that sense, I would say an equal concept, at least in the way that you can use it like any other database as a service, right? So it is MySQL based, so we don't work with Postgres simply because Vitess is MySQL based, so we're MySQL compatible, but it works like any other database as a service, just with the fun fact that, as we told you, schema changes are much easier and you can scale MySQL with it. I hope that answers that question.
Okay. Thank you. Then we have a question from Oliver, who is asking, where is the data hosted? Is it in the EU or European Economic Area? I think it's a bit related to GDPR, the question.
Yeah, it's a good question. Actually, it depends on the branch, right? You can, if you go to any database and you go on new branch, you can decide in which region it's actually being hosted. We will add Frankfurt very, very soon. But yeah, there's already EU in it if you like to. You can even have different regions per branch. In the case of our cloud offering, it's still managed by a US company in the end, but we don't have access to your data. It's all encrypted on disk. For enterprises, they typically decide that they want to run the entire solution in their own cloud subscription. So if you give us your AWS or GCP cloud subscription, we can deploy the entire stack into it, and then we don't have any access to it at all. Only the control plane in this case is still under management of PlanetScale, because we also want to help if anything doesn't work at all, right? We carry the pager, right? The team that joined PlanetScale came from companies who came from folks who ran for instance, databases at Twitter or at GitHub or at Slack, right? Yeah, so on the branch level and in your own data centers, it's a cloud subscription if you want to.
Yeah, I want to add to that we do not currently offer PlanetScale on-prem, because that was another question in the chat as well. But we would be super happy to hear your feedback on that, because we, of course, are structuring our roadmap. So all the feedback you can give us on whether that's a requirement for you, that would be great. I put my email address in the chat.
Okay, perfect. Thanks. That was the next question I was going to take. David has another question, technical one. Do you use subqueries often in real work scenarios?
Well, subqueries, first of all, are supported. It depends where those subqueries are, whether they will be executed efficiently. Right? If we go back to that page with a Vitess architecture, as long as a subquery stays in the same shard, performance is typically great, and Vitess will allow that operation to happen. Right? Like if it's, for instance, about one customer and this customer lives in that particular shard, no problems with subqueries. If it turns out that your subquery is written in a way that it has to go over all the shards, then it depends on the specific use case, whether Vitess says that it can do that query in a performant manner or not. Vitess also supports or protects the database from unreasonable queries that could potentially bring it down, like selects with with millions of rows returned. So it depends, but if you're not using shards, or just one shard, any kind of SQL statement will work. If it's heavily sharded, then it depends where the subquery is. But yeah, if you have a use case, we are very happy to look into it and like to talk to you.
Okay, thank you very much. Another question from Markus. How do you sync database changes with code deployments, for example, during a release?
Well, if that was also something we did not even briefly cover over, but when Lily did this PS merge in here, you can see that there's a deploy request, a GitHub deploy request issued, right? And that deploy request, it first goes in started, then in progress, and then succeeded. And your workflows would basically hook into that particular deploy request event in GitHub to then trigger subsequent changes. And if you wanted to use GitLab instead, then you could build a very similar workflow. It's the entire code for all of those logic is in this repository and can also be easily copied in your own projects. There's also a specific status check, which is only finished when the merge is done. So if you have a workflow that is basically running after a certain status check is reported to pull request, that would work too. In this case, I'm doing the merge here manually. It wasn't possible before this status check was there, but yeah, with a deploy request event or the status check, you could automate this aspect.
Okay, perfect. I think this was the last question. Is there anything else you want to share with the audience?
From my side, not per se. Thanks again, and also thanks to the WeAreDevelopers team for having us for the session. Thanks for the invite. Really nice. And as mentioned, if there's more questions that we haven't answered, feel free to send them to my email address in the chat. I think there was one more question, whether the talk was recorded and whether it can be shared with the people who watched it.
Yeah, absolutely. Everything is recorded, and just a couple of minutes after the event on the same page, you can see the stream, and also in the future on the WeAreDevelopers platform on the watch section. So if you came late or missed some parts, no worries at all.
Thank you.
Perfect. Then, Johannes, please go ahead.
We will also link it in the repository itself. There was other recordings before, shorter, but the more detailed one from WeAreDevelopers, we will just link it over here. And we are very much looking forward to also receiving more examples how this stuff is used or if it's useful, right? Because, we want to improve the way how we integrate GitHub or GitLab and then PlanetScale.
Absolutely. So thank you so much again. It was a pleasure having you speaking here at our event. Hope to see you also at some in-person events maybe in the future. and wish you a very nice rest of the day. Thanks again.
Likewise. Thank you.
Thank you.
Thanks.
Bye.
Bye.
Okay, that was it. That was the WeAreDevelopers DevOps Day for today. But we are going to have our next events very soon. So as you know, every 2 weeks we have one free live event. I think the next one is the Python Day. Then we have Angular Day, I think. Just let me look that up. So many small mini conferences. Yeah, the next one, February 9th, Python Day, March 2nd, Security Day, March 9th, Angular Day, and so on. So stay tuned for a lot of additional developer content, and also check out worldcongress.dev if you're interested to join our first in-person event after 2 years, the WeAreDevelopers World Congress in June in Berlin. And with that said, also, if you haven't done so, you still can win the Nintendo Switch for the next couple of minutes until we close the promotion. And then we are going to announce the winner. So just scroll on the landing page down there and you can answer a question and win the Nintendo Switch. With all of that said, it was a long day with the workshop and amazing sessions in the afternoon. Have a nice evening or a good morning if you are from somewhere else, or a good night. And see you next time. Bye-bye.
Good morning, Berlin!
Everything is being influenced by code written by developers.
At some point, you're going to wake up and say, what the hell am I doing?
It's hard to believe. It's the largest group I've ever been in front of, I think.
We develop the future.